solutions on the board. Your findings, come and present it for us. So come and group items. That's just what you're coming to do. Come and group items. Yes. Yes, you can do group work so that you combine answer and then you bring the results together. Just group items. Try and use one line, okay? From here, from here, from here. Yes, Mm-hmm. Okay, well, So where is this one? This one, the second one, this one. So from which this one and this one give you what? There's the results here, right? Uh-huh. Uh-huh. Come and take the marker. I can't see where you are pointing to. You can even clean everything and solve it again. So wait for him and then you continue. Give the marker to him. I don't have good eyes, so I can't see. Go and sit down. When he's done, then come. So when he was removing the numbers, right? From where? Yeah. Okay. So the person who came to present this has showed us. Okay. So you have made a correction. Thank you. God bless you. Okay. So now you can come to the board. Come back. Okay. Go and group items. Oh, use that stuff. Take. Yeah. Okay. Okay. Please fill up the decimal. Thank you. Give the marker to your best friend. So let's go through before. Wait, let her wait. Let's go through before the grouping. So we have it. So 8n squared with a partner negative 3n squared, right? Are you watching? So in case if there is a mistake, then you let us know. Then the next one, 12mn plus 4mn minus 2mn plus 3mn. Yes. Then the next one will be positive. Is it positive or negative? It's positive, right? Okay. Thank you. Positive 6m squared. Then plus 2m squared. Now your friend, let your best friend come. Come and continue for us. Now come and find the answers for the grouping of the like terms so that the expression will finally be simplified. You don't have any best friend? Give it to her for her to come. Are you done? Thank you. Let's go through it. So 3n squared minus 8n squared minus 3n squared will give you 5n squared. Now let's add all these terms. 12 plus 4, that will give you 16, right? Then we have minus 2, that will give you 14. Then plus 3 again, 17, and then this one will give you, so everything is 10. All right, that is the final solution. Are you okay? Let's move on to the next aspect. Factorization of algebraic expression. So we are going to look at the factorization of algebraic expressions. But we are going to take it step by step. Let's start with the first step. So we are going to look at the first step to be type 1. So we are naming the methods step by step, starting from the first phase, type 1. And it is talking about how to figure out the common factors from given expressions. Common factors. When we say factors, it talks about what the two expressions have in common. Then you take them out. Then the odd ones, the remaining ones will be expressed in what? Brackets. So the first one, we have 3ax plus 6ay. So mostly the expressions will be given in 2 terms, maximum 3 terms. Are you okay? The expressions will be given in 2 terms, maximum in 3 terms. But when it is in 4 terms, you have to group them in twos rather. So we have the 2 terms expression here. Now we need to look for, you see, when we're working for a particular question, then we read somewhere and ask whether that's the final answer. Then someone told me that we need to factor it by taking the common number out. That's the same thing we are doing for this one too. So we are looking at the common number or variable being in our given expression here and take it out. Then write the remainder or the remaining in our common in one bracket. So look at the first question here. In terms of the coefficients and the variables, they might be having something in common. Sometimes it will only affect the numbers, sometimes to only variables, and sometimes the both of them. So what do we apply here? Both of them applies in this section. So you can see we have the coefficient of the first number to be 3, coefficients of the second term to be what? 6. Which 3 and 6 can be in the form of what? The multiple. So 3 can divide 6 to give you a remainder, to give you a number without what? A remainder instead, or a number without any decimal. That is it. So let's try and figure out the common factor for 3 and 6, and that will give you what? 3 being taken out. Then in terms of the variables, which variable do they have in common? So we have a in the first term, a in the second term. So you take a out. Then you open your brackets and you write the remaining numbers for each term. So we have here to be, so for the first term, what is the remaining expression? 3 is already been taken out. A has also been taken out. It is left with what? So we have to write only the x. Then continue with the operation. Then don't write the 6 here. Already 3 has been taken out, and it will divide the 6. Then the answer will be, or the remainder will be inside here. That will give you what? So 3 divided by 6, and it will give you, so you put 2 inside here. That is what has been remained after you divide. Then a has been taken out, left with y, and the answer has been, the question has been simplified. That's the answer. Let's quickly look at the second one. We have 54 minus 81x. Okay, so what do they have in common? 54 and 81. What do you have in common? 27. 27. Do you have any, did they share any variable in common? Okay, so there will be no variable coming out. So what is the remaining expression for the first term? It will be 2 minus 3, and that is good. The last one, we have x cubed minus x squared y. What will be the common term? What will be the common term? X squared. X squared. So we have x squared in brackets. Okay, now this one is giving us cube, and we are taking the squared out. So leaving how many x here? So x exponent 1. Then minus the x squared has been taken out, leaving y. And this is our final answer. Let's quickly move on to type 2, method of grouping. Before we look at example in type 2, you have 2 minutes to try this fourth question for me. 81 u cube then exponent 4 x cube plus 27 u then x y. 2 minutes. Start work. So you are going to present your answer on the board before we start with the type 2. Okay, so stop work. Someone hasn't come to the board before. Who is that? Just raise your hand. They have not come to the board before. Raise your hand. Who? Okay. Come and do everything for us. Do everything for us. Other side. That's fine. That's fine. Is that all? Thank you. Is that all? Oh, take it. You have enough time to. Okay, so let's look at what he has done for us. So we have two times expression here, and which we can use the common factors to make it very simple. So we have here to be 81. Let's consider numbers first. 81 and 27. So what will be the common factor? So that's 27. All right. In terms of the variables, we have u cube 4 exponent n exponent 4 x cube. Then this one, all of them are exponent 1. So we have u here, then here, and x. So all of them are there. So when we have the same variables, make sure you take the one with the least exponent as your common factor. Are you okay? So that's why he has been able to take the one with the least exponent out. Okay. Now the remaining expressions in the bracket. So since 81, um, so 27 has been presented as a common factor, we are not going to repeat the 81 here, but we rather divide to get what? 3. And remaining, so we have u exponent 3 here, and u exponent 1 has been taken out, so it is no more exponent 3, but rather exponent 2. Then we have Vn as well. So Vn is exponent 1, which we are going to get exponent 3 here. We have x exponent 3, which we are going to get exponent 2 here. And y will form part of the last one. So everything has been taken out from here apart from y. So it's left with y. So what happens when everything is being taken out totally? What do you have to present there? 1. Very good. So let's look at the grouping of or method of grouping. So we have the instruction factorize completely. So let's solve these 3 questions under the method 2 or type 2. Starting from this side, so solution. Number 1. This is talking about how we can group them. We are familiar with this one from the beginning. See, grouping of like things. But we are applying the application of sets. So group them into, take their common factor out, then you expand everything, then you finalize your answer. So we have the question to be x squared minus ax plus bx minus ab. So we need to, they are in 4 terms. So So you can't just go straight to the point by taking a common factor out. In fact, you will not even get a common factor from this. So group them in twos. Group them in twos. Then take their common factors from each grouping. Are you okay? So let's do the grouping here. So let's group the first two and the last two. We have x squared minus ax plus, and the second group will be bx minus ab. We have gotten two groups over here, and we need to take common factor from each group. So from the first group, what will be our common factor from the first group? X. Then let's write the remaining terms in the brackets. So the first term remain with what? X. Then minus the second term will be A. Good. Then from the second bracket, we have what? B. Good. We have B into bracket X minus A. So there are some things to look at. After taking the common factor from the two brackets, you must have the same expressions in the brackets. If in this case you have different expressions, they have to go back and check your grouping again from the first point of view, your grouping. Then regroup. Okay? Okay. Now we have here, so let's write our final answer from this side. Since we have the same expression in the two brackets, we just need to present one as your answer. So we are going to present one as x minus a. Then the one in the one outside the bracket will also be expressed in one bracket. That will be x plus b. And this has been simplified. Do you get what we are doing? The second one, we have 2ap plus aq minus bq minus 2bp. So we need to group like, or we need to group them together before we take the common factors out. So by applying the brackets for each group. So what will be the first grouping? Either you maintain the first two last two, or you think you have to regroup it. So what will be the grouping? You should maintain your positions, right? And see. So when you get back to this place and we get different expression in the two brackets, then go back and regroup again. So we have here to be 2ap plus aq in one bracket minus in another bracket bq 2bp. I have reserved this for us to talk about. What sign should it be there? What sign should it be there? Here. Positive. Why? So when it's expanded, you get back the question, right? Good. So positive. Now let's take the common factors out. From the first bracket, what will be the common factor? A. So leaving 2p plus q. Then this one, the common factor will be B. It will left with what? Q plus 2p. Are they the same? Good. So our final answer will be 2p plus q multiplied by a minus b. We have the third one to talk about. Prepare yourself. You are coming to the board again. Okay. Are you still solving? So who has finished solving? Who has finished solving? Or I should give you time. Who is Ibrahim? Ibrahim. Okay, Michelle. Thank you. How many Michelle? Yeah, so Michelle 2. You are Michelle 2. What's the Oh, don't do everything. Just go and expand the bracket then. Let your friend go and continue. Just expand the brackets. We have done something like this before, right? Removing brackets. Uh-huh. Are you solving everything? You want to solve everything? Oh, continue, continue. Oh, use the duster. Write your Z well. Is she correct? Is she correct? Hmm. Okay. Let's move on to type 3 and type 4 together. We are looking at quadratic trinomials. Quadratic trinomials of these given expressions. So we have expression like x squared plus bx plus c. This is a quadratic trinomial of type 3. And type 4 talks about the coefficient of the x squared. Ax squared plus bx plus c. So let's talk about the fourth term because it covers the third term. So this one without coefficients is 1. And this has a specific coefficient greater than 1. That's why you can see the A there, right? Okay, so what strategy are we going to use? So look at this. Any expression with this form cannot be either taking a factor out or group it in twos in terms of the method 2 that we have just talked about. Method of grouping within brackets. It is already in 3 terms. So what you need to do is put up a strategy that will make the 3 terms given to you to be in 4 terms. Then you can apply the method of grouping. Then you find a common factor. So after doing this, by showing all the necessary procedures, We also go by the use of a calculator to see how the calculator can also help us to get the result. Do you get it? So let's do this without using calculator. Then you come back and see the function the calculator also will give us to get the results very faster. All right. In this form, we are going to look at this now, then I'll put up an example to practice. So whenever you get any expression in three terms, whereby the highest power of x is 2 in one of the terms, that will give you the name quadratic. Quadratic. If the highest power of that x is more than 2, 3 and above, so polynomials, we are entering polynomials, and it has a different way to deal with that one too. So this one is talking about quadratic. So we have here the A. So look at this strategy. Most of you are very good by using the calculator, but when they take the calculator from you and ask you to do it manually, you just start to sweat. So just look at how we can do this manually. Use the coefficient of the highest power of x to multiply the constants that has been given to you. So we have the A multiplying C, whatever number it is. So you get A multiplying C. The result that you are going to get, find its factors. Find its factors. The factors must include the positives and the negatives of the same number. Then you combine these two factors by adding them. That's the one that will produce the middle term. So the middle term is B, the one that can produce B as a number. Then you use it to expand the middle term. Let's use a question to get the concept right. Yes, someone is calling me. Who is calling me? Okay. So let's start our example from this side. Let's begin with the type 3 expression of this term. So x squared plus 5x plus 6. So quadratic polynomials of the form x squared plus bx plus c. We are not equating this to 0, that we are going to find roots of the x. No. So this is still in expression form. So there is a strategy. The coefficient of the highest power of x is what? 1. Because there is no number there. Look here. There is no number here. So it is always what? 1. Use that coefficient to multiply the constant. The constant is the number without any variable. And that is the 6 that you see there. It's not the 5x. 5x is not a constant, but there is a variable attached to it. So we have the constant to be 6. So 1 times 6. So this one we are going to have a rough work at this side. So 1 times 6 will give you what? 6. So this is the answer we have now. Now the answer that you have gotten here, try and find its factors. Factors of 6. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So if you find the factors of that given number, take its positive and negative of the same number. Then combine these two factors, that will give you the same result as 6. And when you change the multiplication sign and put the addition sign there, it will also give you a result being found at the second term. Do you get it? So let's try and do the combination. Any combination of these factors, that will still produce 6. Let's write all the possible combinations down. And bear in mind the result here is positive 6. So make sure your combination gives a result of what? Positive 6. Negative 1 times negative 6 will give you positive 6. Give me another combination. 1 times 6 will give you positive 6. Don't repeat what you have written on it. Let's go. Which one again? Negative 2 times negative 3 will give you positive 6. Which one again? And also 2 times 3 will give you 6. Is that all? Is that all? Okay. Now let's look at something. Since we have been able to produce the same results as the question says, then change all the multiplication signs here and write addition sign in place. And find the sum of these two numbers. The one that will give you the same result as 5 as a second term is the one we are picking. That two numbers that we are picking. So this will give you negative what? This will give you negative what? This will give you what? Positive 7. You've not gotten this 5. This will give you positive. So we have gotten the positive 5 here. So the factor that gave us the positive 5 is the one that we are going to choose to expand the middle term. So let's do the expansion. So repeat the first term and the last term. The middle term is the one that's going to change using these two new numbers. So you have and apply the variable to the two of them. So 2x plus 3x. Now we have gotten 4 terms. Now we apply the type 2 to this concept. Method of grouping. So we have here to be x squared plus 2x, 3x plus 6. Then we come up to type 1. Take common factors from each group. What will be the common factor from the first group? Yes, it's what? X. Leaving what the remaining? X plus root. What will be the common factor here? 3. Leaving. So always check whether we have the same brackets. Okay. Then finalize your answer. So our final answer will be what? X plus 2, x plus 3. And that is it. All these are rough work. Okay. Here is the workings you must provide. So, as being a senior high student, all these things are not necessary. We have shortcut to this. Even if you want to do all these steps, we still have shortcut to this. Let's do that shortcut. First of all, let's apply the calculation aspects. So if you don't know the functions, then you learn from today. So we have our calculator. So you take all your calculators. Take all the calculators. Then let's follow these functions. You press mode. We have a lot of functions appearing. So we need equation, right? We are not finding the roots though, but we are using this strategy to get this simplified. Okay. So choose number 5. We have different types of equations. We have simultaneous equations inside. We have quadratic, polynomials, everything inside. But we are dealing with quadratic, right? So choose option 3. Now we have the section where we need to insert our coefficients. So what you see there is the intersection of coefficient to the three terms that you have been given. Now, so there is the shortcut that we are applying concerning to all these. Find the common factors, find the sum, see this, test, and get your two factors, then you expand the middle term. You have a lot of questions to solve in your exam. When you do this, only this will consume like 5 minutes of your time. True or false? Good. So let's do this. Now, after that section has appeared to you, let's type all the coefficients inside. Starting from the first one. You can represent the second term as the first one. It has been arranged. The calculator understand. Bring the first one, second one, and the last one. Don't miss. Don't say that the second one will be given to the first one. It will not give you the right answer. So yeah, the first one has the coefficient of what? 1. So just type 1, punch 1 there. Press equal to. It will enter into that space given to you in the calculator. It will automatically shift to the second term. Let's move on to the second term. Positive, positive, good. So if it is negative, you need to apply the negative sign to the number before you enter. So positive, just punch the 5, press equal to again. It will enter and automatically shift to the third section, right? Let's do the last one. Positive. So you are going to punch the positive 6. Press equal to. When you press the equal to, the 6 has also entered into that given space. Now we need a result. So check something. Press equal to again. The first result comes, right? We want to skip all the finding factors issue. The calculator is doing shortcuts for you. Keep the result intact. We are not finding the 0, so we don't need the final, but keep the result. X equal to what? The first answer is x equal to what? Negative 2. Press the equal to again. The second answer is x equal to what? Negative 3. Good. Now we are writing this as factors. Okay? We are writing this as what? Factors. So we are going to, so x equal to negative 2, 8 factor will be what? 8 factor will be what? 8 factor will be what? Very good. So we have it to be x plus 2. Then this one, 8 factor will be what? X plus 3. I hope you have gotten this. Okay. As you have gotten this, then work backwards to get these missing steps down. Okay. So expand this like multiplication of two binomials. Then replace the missing step that you have missed here in place. Then already the answer has been given, but the missing step wasn't there. So work backwards to get the missing step, then complete it. This is better than thinking, multiplying, finding factors, comparing the two factors, the one that will give you the product of the same answer, the one that will give you the sum of the middle term isn't too long. Are you okay? Very good. Let's look at this question as well. See this question. Let's do something right now. So we are going to form a simple group here. So 1, 2, 3, 4 in one seat, a group. Are you okay? Work together, get an answer, one common answer. You two, one group, one group. And share ideas on how to solve the question on the board. So this question is given to those in this line, three groups. So the next one will come to the rest of you. So discuss on how this question can be solved. Then you present one member from each group. Come in. You are going to provide, you are going to give me three solutions. Then we'll talk about it. The same question. So less than a minute. You are working in groups, so you don't have to even use 2 minutes to get a solution. Do the work together, give it to one person. I'm waiting for the group results. I'm waiting for the group results. Stop work. Thank you. Group 2, what are you doing? The group in the middle. Bring one person to solve the question for us. Group 3, pick the first one. Oh, wait. They have to work together. They have to work together. You have to solve for The next group to come and look at it and do the same thing. Wait, yes, group 2. Group 3. If you are not done, come and continue from the board. If you are not done, come and continue from the board. Thank you. Group 3, what are you doing? I'm waiting for you here. Don't start. Group 3. You know my position, right? Try and do the same. Thank you. You can now begin. Don't copy it. Don't copy. If you are done, can give the marker to me, then take your seats. Thank you. Continue. Are you done? Wear your nose mask. Thank you. You see, it is good to take different answers that you compare, so that you know the different ways some of you use to solve problems, right? Good. Let's look at these 3 solutions on the board, starting from here. So we have the concept called difference of 2 squares. So the person who solved this apply the concept difference of 2 squares, and this will factorize to be in this form, right? Good. Then also repeat the same expression here. Now you see we have 2 terms in our expression here. We have this one, they are multiplying, so minus this, so 2 terms. So we can apply the application of the common factors. So the person tends to factorize by using common factors. So we can see h plus k in the first term, and also h plus k in the second term. So he or she? She took the common factor out, and that is the h plus k. Now, for the side of the first term, we have h minus k. Then this one minus p. So she has skipped a method and just derived the final answer for us. Okay, so what's the method that he has skipped? He has go straight to the point of the expansion. So when during the factorizing, you have to show the remaining number before you you write the final answer. So in this form, this one has been taken out, h plus k. Then this one is left with what? H minus k, then into bracket minus p. So this is the part that was taken out. Do you agree? Before you get the final answer. But anyway, she has done well. Thank you. Let's come to this one to the same thing. The person did not do this one. The same thing. So when you are marking this kind of solution, you know you are going to miss either half or 1 mark for this one, for not showing up a particular step. Let's come to this one. Okay, trying to do something different. So this one we have very interesting one. Are you seeing something interesting on this particular question? It's very interesting. Yeah. Let's talk about this one. Let's talk about this one. Okay, so starting from here, this is a question I gave you, right? So it was this, okay. And she decided to rewrite this as this. Is it equal? Are they equal? No, no. So let's look at the difference between them. We're having h squared minus k squared. And if they are not equal, let me put not equal to sign in the middle and still express them. H minus k all squared. They are not equal. Okay. For this expansion, it described as what? Difference of two squares, which the expansion says h plus k, h minus k. You find the sum, the product of the sum and difference of the same basis, right? Good. Now let's come to this one. Not equal to this because this one talks about binomial concept, right? But what topic does it fall under in the elective mathematics? Got the Pascal triangle concept. Binomial theorem. Binomial theorem, right? So if you use the Pascal triangle to expand this one, it's going to be something different. So let's try and do it and see. So we have this h squared, right? So we have h squared, then you are going to multiply the numbers in the bracket and also the exponent to that we find it here. So you are going to get h times negative k times the exponent 2. That will totally give you what? It will give you what? Minus what? 2hk. Then also find the negative k squared. Negative k squared will give you what? Positive k squared. And this is the expansion to this one. Are they the same? No. So when you are working, you have to be careful the type of the method that you choose to solve your problem. Do you get it? It is always good to make mistakes so that you'll be corrected. Are you okay? Very good. Let's move on. Now, this brings us to the concept of difference of two square itself. Seems like a lot of us don't know what is difference of two squares. So let's talk about this in details. So under factorization, we also have difference of two squares. All of them fall under factorization. Now, before we start with any example, let's look at how it looks like. We have talked about it in the previous solutions that we have been getting. A exponent 2 minus b exponent 2. Now, the concept of difference of 2 squared. Now, look at its name. 2 difference of 2 squared. So, we are always going to have our 2 terms. And the operation sign that will be applied to it is minus because of the word what? Difference. And of 2 squares, which means each term in the expression will be what? Raised by exponent what? 2. That is the meaning of the word difference of 2 squares. And that is an example over here. So we have a squared minus b squared. And whenever we get any expression like the difference of 2 squared, you are supposed to what? Factorize this with this concept. You are going to multiply the sum of their bases and also the difference of each basis. Do you understand this statement? You multiply the sum of the bases and also the difference of each base. That will give you the 2 binomials. Do you get it? So over here we have the sum of each base is a plus b. Since you are multiplying against the difference of each base, you are going to get what? A minus b. So there is the concept of difference of 2 squared. So if you get difference of 2 squared expression or question, you don't have to stress yourself. Go by this principle and just get your answer ready. Let's look at a different question that can be given in difference of 2 squares. Simplification. So we have the left hand side already being squared, but the right hand side hasn't been squared, but the number given to you is a perfect what? Perfect square number. So we need to find it what? The eighth number that can be raised to exponent what? 2. That will still give you the same result. And what will be that number? So we are going to get what? X squared minus what? 6 squared. And when you get the both sides to be in the squared expression, then you are going to use the concept, the product of the bases and the difference of the what? The bases, right? The product of the 2 bases and the sum of the first base and the difference of the second base. We are going to say that x plus 6 multiplied by x minus 6. And that gives you the expression. Let's look at 1 or 2 examples and also move away from there. We have, so second one, x squared minus 1. What will be the expansion? X squared minus 1. X squared minus 1. What will be the expansion? Try and make 1 also to be squared. And is it possible? So 1 squared is same as, so x squared minus 1 squared. And we express this as x plus 1, x minus 1. What happens to this one? X squared plus 49. Okay, let me give the marker to someone come and solve it for me. Or I should do it myself. Okay, tell me the answer. X squared plus 49. Is that what? The answer is someone is saying x squared plus 49. Someone is saying x squared plus 7 squared. So which one should I take? Which one? X squared plus 7 squared. What are you using a 7 squared for? Okay, let me write it. X squared plus 7 squared. What again? What again? Thank you. Is that possible? Look at the sign we have in the middle. It is addition sign. So we can't express this in terms of difference of what? Two squares. Are you okay? The only thing you have to do is check whether they have a common factor and take its common factor out. If they don't have any common factor, the question they gave you is your answer. Are you okay? Good. Now you have 5 minutes to answer these questions I'm coming to write on the board. So we have 3 questions on the board. You are supposed to use 5 minutes. And after that, 3 people will come and solve each question on the board for us. You don't know whom I will call. So you are supposed to do the work. When I call you, then just submit what you have on the board. Okay. Come, come. The remote. 2 minutes to stop work. Less than a minute. Okay, so we have three. We have um, three rows, right? One, two, three. That's columns. Okay. So from here, those are the parts. Come and justify yourself. One person. Who's coming? Then one person from the middle. So you are facing this one. You two. One person from the middle. First, now come to the board. Okay, okay. Then one person from here. Oh, thank you. Oh, there are there are different questions. Then you write the basis in terms of difference of two squares. So that is it. And this one will give y plus root 2, y minus root 2. It's the same thing applied to what we have here. So I was about to talk about it. All right, so let's look at this one too. This one, we have the 100, and 100 is a perfect square number. So you just find the number that can be raised to exponent 2, and that is 10. So 10 exponent 2. Then you quickly do the factorization. All right. Let's use the remaining hour to talk about sets. Okay, sets. They'll go for the second break. All right, so let's look at the definition of the set. Then know how we can solve a problem relating to set. All right, so what is set? What is the meaning to this term? Mm-hmm. Hello. Yes. Okay. Yo, you can talk. You can talk. Uh, yes. A square root which cannot be what? Be written as what? A whole number. Which other definition can you also say about set? Mm-hmm. Yes. I know you have different explanations to this. Give me another one. Okay. So whenever we find square root of any prime number, okay, square root of a prime number is termed as what? Set. So square root of a prime number. Now let's look at the rules governing set. The rules. The rules that we can use to solve set problem. We are going to first look at the reduction to the basic form. So whenever numbers are being expressed in terms of the square roots, you need to simplify this particular number to the basic form. So let's talk about the perfect square numbers first. Perfect square numbers. We have 4. So root 4. We have, let's say, root 9, root 16. So let's find a solution to these three set square roots of the numbers that we have here. So square root of 4 will give you what? 2. So we have the answer here. Square root of 9 will give you what? Square root of 16 will give you what? Good. So all these are perfect square numbers. So as we can find these square roots to be a whole number. So if you are asked to find square root of a prime number, square root of 2, square root of 5, let's square root of 6, square root of then 17. Let's start from the square root of 2. What result are you going to get? Give me the decimal result. 1.44. Give me all the values there. Is that all? Bring all. 2, 1, 3, 5, 6. Is that all? Is it not recurring? Huh? You know, square root of a prime number is what? Non-repeated decimal fraction, right? So this one continues. Just the calculator fill the space for you. It continues. So this one, the answer continues. And look at the decimal fractions there. They are not repeating itself. Non-repeated recurring decimal fraction. Okay. This will also give you the same similar results to what we are talking about here. Now let's look at the 6, square root of 6. Is 6 a prime number? No. But why 6 is being classified as a set? So the product of square root of 2 prime numbers will give you the result also to be a what? In a set form. Which if you find the answer to the square root of 6, it's going to give you something like this. Plenty. The same applies to the square root of 17. So in this, when a question is given to you and I said, you are supposed to try and deduce it by choosing 2 different numbers, then try and find the square root of them if possible. Then you write the final expression as your result. Let's try some examples here. We are supposed to simplify root 27, root 32, root 8, and root 128. So let's look at how we can simplify this. One after the other. So the number that is given to you in the square root, you are supposed to find 2 numbers. When you multiply, that gives you the same result in the square root. That's the first thing to do. But you must consider this. The 2 numbers that you are choosing, make sure one of the number is a perfect square number. If you are not able to find any one of the numbers to be a perfect square number, that root given to you there is your exact answer. Don't do anything to it. Like the 6 that we have there, 6. This 6. We can't do anything about this 6. If we tend to break it down, it will still be root 2 times root 3. And it will still give you what? Root 6. You can't break it down. So, if you are trying to deduce a number in the square root, always consider one of the number you are choosing to multiply against each other should be a perfect square number. If you couldn't find any of the number to be a a perfect square number, the question given to you is your exact answer. Leave it. Are you okay? Okay. So let's take the two numbers as we have discussed. Let's take the two numbers as we have discussed. So give me two numbers. When you multiply, it's going to give you the product to be 27. So what are the two numbers? What are the two numbers? 9 times 3. 9 times 3. And we have been able to discover that one of the number will be a perfect square number. So you need to expand this and say that root 9 times root 3. Root 9 times root 3. Then let's find the perfect square. Let's find the perfect square number from, let's find the square root from one of the perfect square number that we have expressed here. So we have the square root of 9 to be, then we just join the square root of 3 to it because we can't find 8 whole number as an answer. Are you okay? Okay. Let's also look at the 32. Let's look at the 32. What are the two numbers that you can choose? Which one of 8 number will be a perfect square number? 16 times 2. So you write this as 16 times 2. So write them in two separate square roots, which will give you root 16 times root 2. Then our result here, find the square root of the perfect square number here, which will give you what? 4 root 2. Good. Let's look at the third one. Which two numbers are we going to use? 4 times 2. So when we write these two numbers in the separate set, we are going to get the answer to be what? 2 root 2. Let's look at the last one. The last one. We have root 128. Root 128. Root 128. So what are the two numbers are you going to consider here? 64 times 2. 64 times 2. Let's write them in two separate roots. We have root 64 times root 2. Find the square root of the perfect square that we have here. 8 root 2. There's a way we do to reduce or simplify a given set. Let's look at the strategy that we can use to add and subtract sets. So for the set concept, addition and subtraction. It takes the form A root m plus b root m. So let's talk about this one. This concept is talking about when the set is having the common term in the roots. If that is possible, then the coefficients need to be what? Put together, or we find a difference of it if we are dealing with subtraction. So in this form, make sure the terms being contained in the roots, that expression, must be the same. So this one will give you the addition of the coefficients. Then you choose the expression of root n to be a unit added to the result that you are going to get after we have added the coefficients. It also goes the same to the subtraction concept. So this one minus b root m. And this will give you a minus b or root m. So let's take number and put them together. So example, 3 root 8 plus 3 root 200 plus 2 over 3 root 162. So first of all, we need to simplify the roots. Okay, we need to simplify it. None of the roots are the same that we can apply the addition concept to solve. So first, you need to do what? Simplify the roots. So root 8 will be simplified to be, so we have 3. So root 8, which two numbers are you going to use to simplify root 8? We have 4 times 2. So 4 times 2. Then 3 roots. This will give you 100, 100 times 2. And this will give you 81 times 2. In this case, don't write them in two separate sets. Just go straight to the point. Find the square root of the perfect square inside and join it to the one outside. So over here we have 3. So the new number coming outside will be the square root of the perfect square form, right? So square root of 4 will give you what? 2. And the 2 that you are bringing outside will multiply the number that is already what? Outside. And you are going to get what? 6. So 6, then root 2. This one also give you square root of 100 will give you what? 10. So multiply by 3 will give you what? 30 root 2. Then this one will give you square root of 9 will give you square root of 8 will give you what? I've already given you the answer. So that 9 coming outside, you use it to multiply the fraction over there. That will give you, so the 3 denominator there will cancel the 9 and our result will be 6. 6 root 2. Now you can see we have the common roots, right? Now we can add their coefficients. So this is the strategy. We write all the coefficients together in one common bracket. So we have here to be 6 plus 30 plus 6. All against what? Root 2. Now our final answer. Our final answer would be, what will be the result in the bracket? 42. So 42 root 2, and that is our final answer. Are you okay? Okay. Let's look at the multiplication of set. But okay. Let's look at these two examples. Let's look at these two examples. So for the first one, it is also expressed in the form of two binomials. So as it is how we did it for the two binomials, we do the same thing. But just this time, we have what expression of what? The square root inside, right? So the first bracket is always multiplying the second bracket. So let's do that. So take all the elements in the first bracket out. So we have root 3 taking out, multiplying the second bracket. 2 minus root 3. Then negative 1 taking out, multiplying the second bracket. 2 minus root 3. Then what do? Look at the first expand and simplify. So we are going to what? Expand. Okay. So root 3 times the first term in the bracket will give you 2 root 3. Good. Then whenever the same roots are multiplying, what do we do? What do you do? What are you going to get? The same number. Good. So root 3 multiplying root 3 will give you what? Negative what? 3. And we have here negative 1 times 2. That will give you negative 2. Then negative 1 times negative root 3 will give you root 3. Then let's simplify this. Let's group like terms. We have root 3 here, but this one does not contain any roots. So it's also been classified in one aspect. So we are going to continue from here. So 2 root 3 plus root 3 minus 3 minus 2. We don't have any coefficient in front of root 3. So what are you supposed to put there? What are you supposed to put there? So put 1 there. Now apply the addition concept. We are going, since the roots are the same, we need to add their what? Coefficients. So we have 2 plus 1. So we have here to be 2 plus 1 all by root 3. And this one is also having negative 5. Now final answer will be 3 root 3 minus 5. And that is the final answer. We have the second question here. Someone should come and help us with the second question. First, you need to do what? First, you need to look at the second question. This one. You need to do what? Simplify. Break it down. Simplify. Then do what again? Then do what again? Okay. Let's come and demonstrate on the board. Thank you. Do it in the middle. Okay, thank you. Let's go through this. So she has been able to simplify these two sets. We have here 18, so 9 times 2 is the same as 18. 25 times 3 is the same as 75. Then she split this set into two forms. 9 root 9 times root 2 root 25 times root 3. Then this is a perfect square number, so square root of 9 will be 3. Then since they are multiplying, you just join the root 2 to it. So 3 root 2. This one, 225 is a perfect square number, so 25 will give you 5. Multiply by root 3, just add. And good, they are multiplying. If they are adding, that won't be possible. So since they are multiplying, you just add their coefficients and add their roots. Multiply the coefficients and multiply their roots instead. So this one you have 3 times 5, that will give you the 15. And root 2 times root 3, that will give you what? Root 6. And that makes the answer true. Good. Let's also look at the conjugate sets. Before we look at the conjugate set, let's look at how to rationalize set before. So this is talking about the fraction set, expressions that they normally give you in terms of fractions that contains set at the denominator. Okay, so we have a common fraction to be 1 over 2. We have 1 over 2 to be a common fraction. This is the case if the denominator is being affected by a root. Then this is called a fractional what? Set. This is a fractional set. When the denominator contains the expression of what? A set. We need to rewrite this, and this expression is what we call it as rationalization of set. So what you are going to do is that make sure the denominator, which is in the form of set, is being expressed as a whole number. So the strategy is that you are going to take that same denominator and multiply it against the fraction itself, and make sure you are going to multiply it against the numerator and the denominator as well. So we have here 1 over root 2. The denominator is root 2 multiplied against itself, root 2 over root 2. Then you multiply whatever that we have here. So the numerators are going to multiply and denominators too are going to multiply. So 1 times root 2 will give you what? Root 2. Then root 2 times root 2 will give you what? Will give you what? 2. And this gives you the rationalized set. Are you okay? Alright. Let's go to the last one. So we have 2 root 3 over root 3. Let's do this one. 2 root 3 over root 3. The same procedures we are going to use it. Since the denominator is in the form of what? A square root. We need to make sure we express it to be in the form of what? A whole number. And we are going to use that denominator to multiply the fraction itself. So let's do this one. We have root 3 root 3. So let's multiply the numerators and the denominators. So starting with the numerators. 2 root 3 times root 3 will give you 2 times 3, and the answer 6. So we are going to get 6 over, and the final answer will be 2. That is it. So let's build on this rationalization of set and also talk about the conjugate of set. So this is the expression for the conjugate of set. So if you have been given an expression with a denominator in a set form, so let's say this. Root a plus b. Let's assume this is an expression that is being presented in a given fraction, the denominator. So we have root a plus b. When we talked about the rationalization of set, the denominator was only having one expression. But when it has more than one expression, mostly two expressions, and one of its term in that expression contains a root, we still need to deal with it for that denominator to become what? A whole number. And in this form, we are going to apply the term conjugate, conjugating this given set. We also can also call it the same rationalization concept. But how we apply this in the conjugates is quite different from the rationalization. So if we have here to be of two given expressions, this expression conjugates will be the inverse of its operation given to you in that particular expression. So the operation given to you there, if it is plus, its conjugate will turn into what? Minus. If it is minus, then its inverse will turn into what? Plus. Then use that conjugate form of that expression to multiply the fraction by itself. That is the numerator and what? The denominator. So the conjugate form of this expression will give you what? Root a minus b. Is that so? Okay, so let's look at expressions in terms of the fraction. We have 1 over 4 minus root 5. So if there is a root in the denominator section, then we need to apply the conjugate strategy to make the denominator to be what? A whole number. Now, so this is what we do. You take the fraction being given to you, that is 1 over 4 minus root 5, and apply its conjugate and use it to multiply the same fraction, both the numerator and what? The denominator. Then we find our result. So over here, the conjugate of, what's the conjugate of the 4 minus root 5? Who can help me? 4 minus root 5. Yes, that is it. So 4 plus root 5 over 4 plus root 5. Then we multiply the numerators and what? The denominators. Let's do that. No one multiplying any number gives you the same number, right? So for the numerator, we still have the 4 plus root 5. And let's do the denominator here. Over we have 4 minus root 5 multiplied by 4 plus root 5. Open your eyes and tell me something concerning the denominator. Uh, so the denominator is expressing some idea. And what is that? Uh-huh. Difference of two squares. That is it. That's the expression over here. And so, in which way can we deal with this to get the whole number? So, work out the difference of two squares here and give me the whole number from this. Yes, work out fast, fast. If you get the answer, then raise your hand. They refer to us. Yes, 11. So, give us the expression in the difference of two squares before you get the answer to the 11. Yes, 60, 16 minus what? 5. So 16 minus 5. And so let's put it in the fraction form. So we have here to be 4 plus root 5 all over what? 16 minus 5. So we know 8 to be 16 minus 5. So let's write 11 there. So 11. And this gives us the final result. We don't care whether the numerator also contains a root or whatever. We have to make sure the denominator is a whole number. Whenever there's a root there, try and manipulate it using, if it is just one term, one expression, then you have to rationalize it. If it is two terms, then you have to find its conjugate instead. Are you okay? Okay. Let's look at examinable question under the conjugate. How to give us example 2. So this is an examinable question. It said express 2 root 5 plus 5 root 2 all over 2 root 5 minus 5 root 2 in the form Q plus R root S, where Q, R, and S are rational numbers. Where Q, R, and S are rational numbers. All right, so let's do this in groups and come and share our ideas together. Let's do this within 5 minutes. Now I come to the middle group. So we have the first and second rows over here, right? We are going to form a group. 1, 2, also a group. Okay, brother, join them. So in a way, how you come together and find a solution to this. Try and combine ideas. You have 2 minutes. One minute. How many groups do we have there? Two. So each member from one member from each group should give us one person, or one member from each group to come out to represent the group work for us. So for those who are coming here, you are going to use all this space for your solution. And for this side, you can divide it into two and also continue to from this side. So come forward. Who is coming? Bring the solution that you have, then we will talk about it. Mhm. Who is coming? Group one at the back. Bring someone. They are coming to solve it together. Yes. Okay. Then group one. Who is coming? The champion Annabelle. Come and do it for us. So take this out, Annabelle, and take the duster if you want to clean. Don't clean with your hand. Please keep quiet. Okay. Okay, you can put a marker down. Uh, come back. Come. They say you should write it in a form. Then you have to state the numbers for each variable. The value for K, R, and S. Okay. Okay, thank you. Okay, let's go through this fast. We have the first one here. So he started by finding the conjugate of the given set because the denominator of the set is in the form of what? A root. And it is of two expressions, two terms. So we need to find it conjugate by doing this. So that is check. Then also you should be able to multiply the numerators and the denominators. So we have here, so this multiplies all of this multiplies all of this. Then we have here to do squared. So this one is also in the form of difference of 2 squared, the denominator, right? Alright. Then let's simplify the numerator here. We have 4 times 5. Okay, 4 times 5 here. Then we have 10 times root 10. Okay. Then we have 10 times root 10. Then we have 25 times 4. Alright, so we have it here 20 roots 10 plus 50. And the denominator here is supposed to be Five, 4, 4 times 5, then 25 times 2. All right. So after simplifying, we have 70 plus 20 root 10 over negative 30. So that's we have 20 plus 50. That is 70. Then 20 root 10 over here. Then let's simplify this. So write them in separate fractions. So we have here to be 70, where is it? So negative 70 over 30 minus 20, so negative 20 over 30. Okay, so all of them. Then you simplify. This will give you negative 7 over 3, negative 2 over 3 root what? Root what? So this one's supposed to be what? 10. Okay. All right. But should I write them at this side? So now we can define what we have here relating to the instruction given there. So Q plus R root S. So this, the constant here without any uh, roots is our Q. So our Q is equal to negative 7 over 3. And the coefficient of the S is our R, and that is also negative 2 over 3. And the root itself is the S. That is the root what? The S supposed to be 10, not root 10. Are you okay? So the S supposed to be 10. They only take the S from the root, so don't also define the root. So over here, we are going to say S is 10. I think checking for 1 is okay. So let's look at the final answer over there. Okay, so what's the mistake we have here? So let look at this. So remember the denominator was the one having um, the negative sign, right? So if you tend to write the numerator in separate fractions, it will go along with the same denominator. Are you okay? So we have here to be negative, so 70 over negative 30, then plus 20 over negative 30. Look at this one. Root 10. Okay, because we have the minus and the plus here, over here is going to be what? Minus. Do you understand? Okay. Then you further break it down to get a similar answer like this. Are you okay? Good. Let's look at the radical equation. Keep quiet. So break down. Right. Let's manage this breakdown. radical equation. This is the aspect that you are going to introduce equal to in our expressions and find a way to solve for it. Find a way to solve for it. So let's look at some of the questions. So this is an example of a radical equation because of the introduction of the equal to. Because of the introduction of the equal to. Because of the introduction of the equal to. So let's see how we can solve for this. Alright, so whenever you get a question like this, which deals with the set and its equation form, you must group like things. Make sure the set is always written in a positive form or the set is in a positive state. Are you okay? So we have two sets over here. We have here square root of the expression 3x plus 4 minus. So make that set that has been given a negative to become positive. So what do you do? By taking it to the other side of the equation. Alright, so let's do it together. So we have here to be root 3x plus 4, then making this set positive by sending it here. So we have here to be 1 plus root x plus 4. Now, we need to find a way to deal with the roots so that we can have whole numbers and deal with it and get our final result. So what we need to do to get away the root will be what? The introduction of the what? Square. So we are going to introduce square to the both sides. Are you okay? We're going to introduce square to the both sides. So this one you have to put bracket around it. So now let's apply the square. This square automatically cancel the square root from this expression. It's 1. So we are going to get what? 3x plus 4. But we need to use the concept of the Pascal triangle to expand this one. That is exponent 2. So let's do that together. We have 1 squared is the same as what? 1. Then 1 times the roots multiply with the square also here will give us what? So positive what? 2 root what? X plus 4, then plus the whole expression with the square will give you what? X plus 4. Are you okay? Well, look at how the Pascal triangle is playing in this particular question. Binomial theorem expression. That's what we are applying here. Alright, so we still have the roots. But let's first group like terms then so that the terms over there will reduce. Then we know what to do. So we have to group all the x together. So we have here to be 3x at this side. So we are going to bring the corresponding term of the x to join the 3x to be negative what? X. Then also group the constant to that particular side. So over here, let's add them together. 1 plus 4. Then send it there to do what? Negative 5. Equal to 2 root x plus 4. So we want to still... There is 4. Okay, so I did not notice that one. So let's add that to it. Then that's completed. We are in concern to make the square root to disappear. So that's why we intend to make the square root to stand alone. Okay, so let's also simplify the left hand side and know how we can still deal with the square root at the right hand side. We have here to be what? 2x, then minus what? 1. Good. Equal to the expression at the right, 2 root x plus 4. Still, we have square root in our expression, so we need to also apply what? Introduction of the square to the both side again. Okay? Okay, so let's continue from here. 2x minus 1 equal to 2 root x plus 4. Then introduce square to the both sides, not the individual terms, to the what? Both sides. We only have two sides in our what? Equation. So in this state, all the terms over there will be what? Be collectively in a what? One common bracket. So this one is going to be in bracket, then exponent 2. Then this one also be in bracket, then exponent 2. Now this one will allow the square root to be eliminated. First, let's simplify what we have at the left hand side. So we are going to get 4x squared, right? Minus 4x plus 1, right? Then this side I'm going to get 4 multiplying what? X plus 4. I hope you know how to go about this, right? Good. Now, there is no more roots, square roots in our expression anymore. So what we need to do is, we have a bracket there, so you expand the bracket, group like times, then you find our result. So this one is going to be 4x squared minus 4x plus 1 equal to, expand the bracket, we are going to get what? 4x plus 16. Alright, so let's group the like terms. Since we have been able to discover the quadratic expression or function over here, we need to group all the expression to one side and equate to 0 because we need to find the roots. Do you get it? Alright, so we have 4x squared minus 4x, then minus 4x again, plus 1 minus 16 equal to what? 0. And we get 4x squared minus what? 8x minus what? 15 equal to 0. So this has been able to, we have been able to derive to the concept of what? Quadratic equation. This is not expression. Quadratic what? Equation. So let's use our calculator to find the root quickly, then bring it back into our expression here. We'll go back to the manual way of using the A to multiply the C and others. So let's use the calculator to find the root. So the step that I showed you, try and use it then. Give me the roots. Or we should go over the steps again. I hope you know it. Alright, so apply it and give me the roots. Then we'll transform the root back into some of our method that needs to be there before the final answer comes. So let me write it down here. X is equal to the first result for x is a fraction with the numerator what? Negative, is it negative 2 or 2 minus? 2 minus root 19 over, really? Gotten a complex answer, right? This is a complex answer. So let's take it like that. Then the second answer is same thing, but plus. So that is plus or minus, right? Okay, so we have it to be 2 plus root 19 over 2. We are not supposed to get complex results. Okay, so in this form, you need to end like this. Either you state the complex answer as your final or you end in this form. Are you okay? So let's try another one if you have enough time. Okay, so let's reduce whatever that we have done within our stimulated time left here, 2 minutes, and see the way forward, how much we have learned, and go for the second break and resume our next section. So we have been talking about sets, and we have been able to find how to rationalize sets. So, okay, so that is it. So we first looked at how to simplify sets, and we talked about you should be able to find two numbers when you multiply. That gives you the result being the number being defined in that particular set, and that particular number that you are choosing, you must at least make sure one of the number is a perfect square number, so as the result will be valid. If none of them will give you a perfect square number, leave that particular set as your answer. And we also talked about how to multiply sets. How to rationalize, and that one, whenever the denominator, whenever the denominator of a given fraction is in the form of a set, whenever the denominator of a given fraction is in the form of a set, you need to find a way to make that denominator to be a whole number by using that particular denominator which is in the form of a set, by multiplying the fraction by itself. And therefore, since set of the same kind when they multiply gives you a whole number, then our denominator becomes a whole number. So in this case, in this case, we are going to have our next break for the second activity. So I declare break for the second activity, and the break starts now. Hello, hello. All right, we have resumed from our second rest. We are going to also look at another one important concept in mathematics, and that will be under rigid motion. That will be under rigid motion. I hope you have your graph books with you. All right, because we are going to do a lot of activity for this particular lesson. So let's look at the introduction to the topic, rigid motion. Rigid motion. So let's see this. So if you tend to walk from one place to another place, what is the effect of you, the individual, moving from a place to another place? Now, from this scenario, you notice that it is the position that has changed. The position where you were has changed from a place to another place. But you being the object or the individual do not change in shape or size. You do not change in either shape, the form of shape or size. So the concept of the rigid motion states that when an object moves from a given place to another place without changing its form of shape or size, and it has its name to be called rigid motion. Are you okay? Rigid motion. Now we are looking at the aspects of the rigid motion. We can talk about translation. We can talk about reflection. We can also talk about rotation. All these aspects fall under rigid motion, whereby there is a change in direction of a given what object from a place to another place, whereby the shape and the size of that particular object or figure does not what change. So, looking at the concept of the rigid motion, we are first going to look at translation. We are looking at translation. So, translation has this principle. So, it says that if a figure is moved in a straight line by a certain amount in a certain direction without turning, then the figure still looks the same. that we can also describe as translation. Remember, translation is also a, it also forms part of the rigid motion. So it takes the characteristics of a rigid motion. So let's look at the real life examples of translation. Number one, when you walk from one place to another place, translation takes effect. Number two, when you push a table away from a given place, translation also takes effect. When you lift a bucket of water, translation also takes effect. Now, we have rule for translation in terms of mathematical expressions or questions being related to translation. Therefore, we are expressing this in terms of a rule, so as we are going to use to find the possible given point that a question will be demanded. Let's look at the format for a given translation. So let's assume a given point to be xy. Whenever we plot a point, it consists of the x coordinates and the y coordinates. Is that so? Good. So we are using points. In this case, we are not using a real object. We are using points. So when you plot any point on our graph, a given structured graph, then we want the position of that point to be moved to another place. Then we use a formula or a rule and apply accordingly to get that particular movement right. So this xy gives you the given point that we don't know yet. And it is of the form in terms of translation. We have this given point repeated as xy. Then we have what is called the translation vector. So we are going to add translation vector to that given point, and we assume the translation vector to be AB. It is also expressed in terms of the xy coordinates. So we also have it to be in the form of coordinates AB. Then you can use the concept of algebra to get your results, which these are variables. So you just have to show the addition of these. We have x plus. So you add the corresponding x values and also add the corresponding what y values. So we have here to be x plus a, y plus b. So let's describe this rule. So as I begin stating the meaning of this xy, that is the point in question, to call it original point. So this xy repeated here is known as the original point. Then the AB that we have introduced is transporting us to a new destination. So that point is moving from a given a destination to another destination by the transport of what? The translation vector what? AB. So we have the AB to be named as our vehicle, and it is called translation vector. Then what will happen when a given coordinate or point has been used to take effect on our original point? Surely you are going to get a new point, and now the new point becomes the image of the original point. Do you get it? So the result that you are going to get afterwards will be called the image. Going to be called image. So this is the labeling of the rule or formula that explains the translation concept. Let's try. So writing the rule in this form can also be written in this form. So instead of writing this in forms of the vertical form, you can also write it in terms of the horizontal form, which this can also be written as xy map to xy plus ab equal to x plus a y plus b. They are the same, but they are more friendly to deal with when you choose the first one. Are you okay? All right. Let's look at some of the questions that we can use the translation vector to solve. So it has the title Translation of Points by a Vector. Translation of points by a vector. So the first question here, so we have it to be finding the image when finding the image when the point and the translation vector are given. So with this expression I'll give it to you here, you can be asked to find any one of them. Any one of them when it corresponding other two informations have been completely been given to you. So let's look at this. We have original point, we have translation vector, we have image. So they can decide to give you the original point, the translation vector, and ask you to find the image. They can also be giving, you can also be giving the original point and the image and ask you to find the translation vector. They can also give you the image and the translation vector and ask you to find the original point. So this formula over here can be transformed in different ways to be given to you as a question. So we are looking at the first point on how a question like that will be given to you. And the title to this is finding the image. So this time we are going to find the image. So finding this one when original point and translation vectors has been given to you. So let's look at some of the examples here. So let's have a look at this question here. So from this question, it says, find the image A prime or A complement, A prime, or a symbol for the image. So it is not necessary to be A prime. Sometimes even naming the image can be written down here. It doesn't describe, like it doesn't make any difference. Okay. All right. So in this form, we have it to be here. If the original point is 3, 4, and has been translated by the vector -2, +5. So you use this format, then just answer. So what you have to do now is we have to recall the rule given to you, then apply and get your result. Simple. Are you okay? Try and recall some rules down. So when necessary, you apply them to solve your problem. So let's use this rule to answer. So we have the original point. So follow up with this one. So original point is given as the xy. But this time we know it is no more xy, but it is what? 3, 4, right? So we have here 3, 4. Map to the same what? 3, 4. Then we add the translation vector given in the question to it. It is no more AB, but negative 2, positive 5. So we have it here to be negative 2, positive 5. Being equal to, then this one, there are numbers. So we can manipulate and get a single result, particular result or a coordinate. So add the x values and the y values, then represent them. And bear in mind, please, most what I've encountered is most students, when they are dealing with coordinate or vector expressions, they normally forget themselves and express it in terms of fraction. Sometimes you have an answer to be 2, 4, and the person will simplify this to be 1, 2. It's not accepted. Are you okay? Some of them even intentionally write over underrate because they like fraction too much. So please, let's stay focused to what we are doing and no simplification anywhere. So let's have our final answer. So 3 plus negative 2 will give us positive 1. Then 4 plus 5, positive 9. Yes, I like that. So we have to be specific. The 9 we are talking about, is it positive or negative? Okay? Okay, so our answer is 1, 9. So we are going to write the final answer in terms of a simple expression relating to our point. So you are going to say that therefore, so the image of the A point A is 1, 9, and that is just simple. Are you okay? Let's have a look at this one too. So now you should be able to recall. So I'm going to claim the rule. Okay. So we have the second example. I started with A, so the second one is B. So this is the question that we're going to solve, but it is 2 in 1. We have 2 given points using a common or a single translation vector. So let me do the first one, then the second one will be for you. So let's apply the rule given to us. So find the image of the first point 1, 2 under the translation vector negative 3, positive 4. So we have here to be 1, 2 as our given point, and the rule for the translation vector says we should add. So we have here 1, 2 again, then add the point to the given translation vector or vector that was given to you here. Then we have here to be negative 3 and 4. Then our final answer will be our image. So 1 plus negative 3 is going to be negative 2. 2 plus 4 will be positive 6. Don't simplify, please. Are you okay? Don't say negative 1, 3. It's not a fraction. All right. Let's go to the second one. Someone will be coming to the board to do the second one for us. So I'm giving you this space. So come and do the second one here. The given point is negative 2, negative 4. By the vector negative 3, positive 4. Okay. You are by name Angela. Okay. Those are the back. Can you see from the board? Thank you, Angela. So we have the translation vector to be negative 3, positive 4. The translation vector to be negative 3, positive 4. Then you are supposed to add it to the point given to you and get your image after you find the sum of the x and y coordinates. And that is the expression that Angela has given to us here. And it is true, right? It is true. Let's move on to another way that a question can be given to you in terms of using the rule of the translation vector. So the second way that you can get a question from is finding the point. When the image and the translation vector are given. So I've already told you about the rule. As the rule has been given, you can be asked to find either the original point when the other two information has been given, or you can be asked to find the translation vector when the other corresponding two information has been given, or finding the image that we just looked at. So this one is talking about finding the point. So the point is the original point we're talking about, which means the image and the translation vector will be given. So this is the case that when they only give you one aspect of it, lacking the other two, don't attempt the question. You can't solve it. They've given you a point, no translation vector or no image, but they are asking you to use the point to find a translation vector in the image and so on. No, that one does not exist, right? So always two information must be given for you to solve for the other one. So let's look at this one and how we can also apply this rule. So we have first question, the image of point P is given as 4, 6. So this is the image of a point P under the translation vector vector 1 to find the points. Find the points. So find the original. They will not add original points. They just say find a point. So you should know it is the actual point you are supposed to what? Find. So let's apply the rule given to us for the translation vector, and we'll go according to what the rule says. Are you okay? So first, you have to write the format for the translation vector. Write the format. So the format says xy map to another xy plus ab equal to x plus a y plus b. Then let's look at the question and use the right information to substitute the correct places that the rule gives us and see what we are lacking and try and find it. So from the question here, we have the image given. So this place is going to be replaced by the image. Let's do that one first. So we have x, y, map to. So let's skip everything here and come to the image side, which is 4, 6. Watch here of a point P. So the point wasn't given, but the translation vector is, so we have a translation vector here, which is 1, 3. So the original point wasn't given. So 1 was 2. Good. All right, so we have this expression being written to favor the person that has been given to us. Now, let's focus on what we need to solve. We need what? The original point. So, it goes like this. You are going to add the corresponding x value equal to the corresponding x value, the answer that they give to us at the image side. Do the same thing at the y coordinate as well. So over here, you are going to equate x plus 1 equal to what? 4. Find its answer before you come to the y value. So we have here to be group like things. Let x be the subject. 4 minus 1, right? And x is equal to what? Positive 3. Let's come to the y coordinates. We also have y plus 2 equal to 6. Make y the subject. 6 minus 2, that gives us y equal to what? 4. Now let's conclude this. So therefore, so the point, what's the name of the point? P. So therefore, our point P is giving us, what's the x coordinate? 3, and the y coordinate 4. So that is our point. So our point is 3, 4. That is it. You can even rewrite in this form. You see, the point wasn't given, so you are going to say that xy is equal to 3, 4. This one too is also good. So this is how we can also present answer in this form. Let's also look at the third way that the rule will be defined in different aspects of the questions. So the third way is that you are going to find the translation vector when the other original point in the image has been given. So let's put this into examples. Remove it. Okay, so let's look at this example. So in this example, we have the image to be 2, 4, and the original point is also 1, 2, and they are asking us to find the translation vector. So let's go by the rule for the translation vector. It says xy map to xy plus ab equal to the image x plus a, y plus b. So let's look at the information we have here and substitute the points accordingly in the rule. So we have the original points given and we have the image given. So let's do that. The original point is 1, 2, and the translation vector wasn't given. So let's repeat that. And the image is 2, 4. The same strategy that we used to solve the previous example, that's the same way we are going to also use. Equate the x values. So we have the x values, that's a is present over there. So we have 1 plus a equal to 2. Make a the subject. So a is equal to 2 minus 1, and a is equal to what? 1. Do the same for the y values. Equate the y values. 2 plus b equal to, make b the subject. 4 minus, and b is equal to. So therefore, the translation vector, so let's write in statement. The translation vector, is, so the corresponding x value represents the a, right? So the number we have there is what? 1. And the corresponding y value is the b. That is what? That is 2. And this is the translation vector. I hope it is easy. Very, very, very easy. So let me give you this one. to for you to also practice. Practice makes perfect, right? So our second question, question B. Under a translation, the image of the point 54 is 7 1. Watch this question carefully. What is the image of the point 1-4 under the same transformation? How can we solve this? Can someone help us? Yeah, so look at the question again. Under a translation, the image of the point 54 is 7 1. What is the image of the point 1-4 under the same transformation? What are we looking for? Trans what? And image. We are looking for translation and image. So how can we get, so which one are you supposed to find first? Then you need to solve the image, right? So who is coming to help us? Who is called honorable here? I just say head of honorable. Incoming honorable in future. Yes, honorable, please come for the marker. You deserve the post. Come for the marker. Let's clap for honorable. Let's clap for honorable. Come for the marker and help us to solve the problem here. So you can start from here and continue from the middle. Okay, now let's look at what we have here. Let's look at what we have here. We have the question to be You said we should, according to this, you said find the translation vector when the original point in the image has been given to you. Okay. So Honorable has been able to find a translation vector, and their answer was 2, -3. Okay. Then you use a translation vector to also find the image when this becomes the original point. Then the answer has also been given. In this case, you need to also define like what you did here, the image. So therefore, the image is 3, -7. So this one is better. You have done well, Honorable. Let's have a look at the last question under the translation vector. Then we'll look at how we can graph this using our graph. So this one is for all of us in 5 minutes. So find the solution to this in 5 minutes. And your time starts now. 1 minute more. Okay, so let's look at the solution. Should I do it myself? If I wanted to do it myself, I would have given it to you to try. So you have to come and help us with the solution. So who is ready? Michelle. Please, Michelle. But you are Michelle. All the same. Let me help you break the cover. Are you done? Okay. Michelle is done. So let's look at what she has for us. So let us understand the question first. So the K prime is the image of K under a translation vector, which maps to P, the original point P34, onto the image of P76. Find the coordinate of K prime. So first you need to find a translation vector using what? The P and the P prime. When you're able to get it, then use it against the original point Q to get the image of the Q, which is the Q prime. So let's see whether he was able to do that. So the original point P has been defined here. So, okay, so that's the same thing that she has done. So we have here check. So to get a translation vector, you need to equate the x values and the y values separately. So we have that here. And you make the A the subject, do the same thing for the y. Then the translation vector is the combination of the x and the y in terms of the coordinates, that is 4, 2. So using this information, that the translation vector that you have derived now to solve for the image of the kill. So we have here to be, so okay, original point is 2, 1. Okay, so after that you have been able to solve everything, you need to write the final expression that makes everything meaningful. So you just have to say that, therefore, the kill prime is giving us 6, 3. Are you okay? Okay, so let's look at the graph presentation under the translation. Using a scale of 2 centimeters to 1 unit on each axis, draw on a graph sheet two perpendicular axes OX and OY. On this graph sheet, mark the x-axis from -5 to +5 and y-axis from -5 to +5. Plot the point. Point A, 1, -1. So -1, -1, further. Then B, 3, 4, and C, 2, 1. Join the point to form a triangle. To form a triangle. Draw the image of the triangle ABC. Under the translation, by the vector 1, 2, negative 1, 2, such that so there is the graph related question that we can get under the translation vector. So let's look at what the person is saying, then we'll go by the rules given in the graph. So let's all read the question together. Kenneth. So as you read the question, you need to also take your time and understand the instructions given to you in the question. So let's demonstrate this on our graph. And I know you also have graph, right? Okay. So from what is given to us here, so using a scale of 2 centimeters to 1 unit on both axes. So we are using a graph sheet to draw two perpendicular axes. So this will be our graph sheet. So let's try divide this into two equal parts. Please, as I'm drawing my graph, you to do the same. So I have my two perpendicular axes. We have it here, y axis. Third, we should name it OX and OY. So let's do that. So over here is going to be OY. Then we have here to be OX. Then make sure you enclose all the 4 points with arrows. Let's look at the scale. So They are asking us to mark from the x-axis -5 to +5 using 2 centimeter to 1 unit. So every big box, you are going to make an interval numbering to be what? 1. Okay, so the difference between the numbering will be 1 for every 2 centimeter box. So for the x-axis, we have 2 centimeter to 1 unit. So we have here 1, 2, 3, 4, 5. Then the negative side, we have -1, -2, -3, -4, -5. Then for the y-axis, the same thing from -5 to +5. The same 2 centimeter to 1 unit. So come to the y-axis, we have 1, 2, 3, 4, 5. -1, -2, -3, -4, -5. Now let's begin our plotting. By now, I know you have been able to draw your perpendicular axis. Let's do the plotting together. So the first point, we need to plot the point A, which is -1, -1. So we can find it here, -1 on the x-axis, -1 on the y-axis. They will meet here. So just to create a point there. Then you write the coordinates beside the points with its name. So A, -1, -1. Let's also look at the next point. We have B, that is +3 for the x-axis and +4 for the y-axis. So we have it to be here, 3, 4, and they will come here. And the name is point B, 3, 4. The last one, we have +2, +1. So we have +2 here, +1 over here. And that is the point C, +2, +1. Then they are saying we should do what? Join the point to form a triangle. Join the point to form a triangle. So let's do that. So match up the first point to the second point. So we have the A given to B. Then you draw from B to C. Then you enclose the other side. So this is our given triangle. Now you also get the same shape, right? Okay. So let's look at the image they are asking us to plot. So the next question says that draw the image of the triangle ABC under the translation by vector -1, -2, such that A maps to A1, B maps to B2, B1, and C maps to C1. So with this one, they have given us a specific rule to use. This is the rule, translation by vector. So you need to apply the rule that we have previously talked about. Find all the images using the rule and make sure you show working whilst getting the images. Then you plot them onto our graph. So we have the solution. So let's do the solution for the images, then plot the points. Starting with, so this one, you can just say rule once, then use it to get all the images. So let's take the rule first. So the rule says that xy map to xy plus ab equal to x plus a y plus b. So for the point A, we have A to be negative 1, negative 1. And that will be given to the translation vector defined here. Okay? So we have it to be negative 1, negative 1 plus negative 1, negative 2. And our image will be derived from there. That will give you the A prime. And this will give you negative 2. And this will give you what? Negative what? 3. Let's do that for B and C together. So B was also been given 3, 4. So we have 3, 4 map to 3, 4 plus negative 1, negative 2 equal to the image of the sum of the x and the y coordinates you are going to get from here. This will give you 2, and this will give you also what? 2. Then the last point C, that was given as 2, 1. We also do the same thing for the point C. So plus negative 1, negative 2 equal to negative 1. Oh, that is positive 1. Then negative 1. Good. Now we have gotten all our points for the image, right? All our coordinates for the images. So we need to show it on the graph. So let's do that. I'm going to plot the first one. Negative 2, negative 3. Where will it be? Negative 2, negative 3. Here. The name is A prime, negative 2, negative 3. Now we have B prime, 2, 2. So positive. So positive 2, positive 2 over here. And we are going to get the name to be B prime, 2, 2. The last one, C, 1, negative 1. 1, negative 1. That is C prime, 1, negative 1. Then join, look at it, it said draw the image of the triangle, which means our image will also form a triangle. So you have to close the points to form the triangle. Let's do that together. Okay, so try and get the similar triangle like my own. Your own might look better than my own. Okay, so did you get the same thing? All right, so that is it. So this is an example concerning graph only for translation. So when we move on to the other forms of the reading motion, its own aspect also what come. Are you okay? Now let's move on to reflection in a line. So we are done with the translation. Any question? How to use the translation rule to determine images and also how to apply it onto a given graph. There's no question, right? All right. So let's look at the reflection in a line. So can I clean this? Okay. Reflection in a line. So you have been hearing of reflection. So we have been using um, the aspect of the reflection concept always in our daily life, right? What is common to us is the mirror that we have been using in our rooms to dress up, okay? And what makes this mirror look so special under the concept of the term reflection? Whenever you want to see yourself again, you tend towards visit your mirror for your mirror to describe who you are to you, isn't it? Somebody tells you on the roadside, today, dear, you look beautiful. Quickly, you really want to rush home for your mirror to confirm for you. So as for the men there, you don't get any compliments. But the ladies, they always compliment them. So this mirror is serving us um, a particular purpose, mostly telling us how we look like. But we have special properties concerning this mirror. Okay, so as we being the original object facing in front of a mirror, we have some properties that a mirror observes to us. The distance that we are to the mirror will correspond to the same distance our image creates with the mirror. Okay, this is one of the properties you can observe when using a mirror. And you see your own self again in the mirror. But the only difference is that you will be invented. I hope you understand. You are going to be turned in the opposite direction. So, in a normal sense, whenever you visit your mirror, you should have seen your back. That's a normal sense. I hope you understand this. Whenever you visit your mirror, you shouldn't have seen your face again. You should have seen your back. So, seeing your face again tells you that you have been turned around, you have been invented. So, the mirror has changed your direction. So, this is the concept about reflection. This is a concept about reflection. But the only purpose it gives you is whenever you look inside a mirror, whatever that you see is you. The mirror will not do you makeup. The mirror will not do you makeup. The mirror will not make your nose to be two. As it is, so shall it be that the mirror will give to you. But the only property that we should take notes about is the inverted part of the object we are using against the mirror. Apart from that, your distance from the mirror is the same distance from your image in the mirror, and your own self is the same thing as what you also see in the mirror. So we are bringing this reality aspect into mathematics. In this case, we are not going to the market to buy any mirror. Our mirror is in our book, in our graph book. We have to see ourselves through from our graph book. Yes, and that is the axis that we form in our graph book. So we have the first mirror to be our x-axis. So whenever you draw your x-axis, you can stand on top of it. You can see your image down by observing a given, not in reality aspect. Are you okay? By observing a given. So as our y-axis can also serve as a mirror to any given figure or point by observing a given what rule. Now let's look at some of the rules that can be given in the reflection concept and see how we can apply some of them in our graphs. So let's look at the rules here. Rules for special reflection in a line. Rules for special reflection in a line. Beginning with, so the rules we normally know them as formulas as well. So all of them are in the same form. So our first rule, reflection in the line. So let me start with in the line, y equal to 0. Reflection in the line, y equal to 0. So just observe this. In our graph, we only have two known axes. That is, what are the two known axes? X-axis and what? Y-axis. So if they are referring a given axis to be equal to 0, actually which axis are we talking about? Which axis are we talking about? X-axis. So when they ask you to reflect a given point in the line y equal to 0, it is not y-axis they are talking about. Y has been taken off. That is why they are equated to 0, which means they are talking about the other one, which they have not even mentioned. So this in the line y equal to 0 also means in the x-axis. Are you okay? Then it has a given rule. Let's take that one. Even let's demonstrate this on a graph so that you'll be clear with the rule by yourself. Let's assume, so we are talking about reflection. So we have our x and y mirror here. X and y mirror. So this is our y mirror. And this is our what? X mirror. So always, whenever a Cartesian plane is drawn, always we start from the quadrant which creates both the x and the y axis, or x and y coordinates to be positives. That's where we always stand to perform any activities afterwards. So we are taking this particular side here, which makes our given point all positives, both the x and the y axis. So let's assume a given point xy. Let's assume a given point what? Xy at this particular quadrant or place. Then we are talking about x-axis. So what is the immediate, or where is the immediate x-axis given to our given point xy? Where can it be found? We have two of the x-axis that we can consider, but always look at the one that is closer to the point we are talking about. Okay. So over here we have x, one of the x, because we have divided into two. One here, one here. This one is far away from this, so we have to just use directly like this. Mirror, we don't go and stand anywhere far to go and observe the mirror. Just get closer to it. So this serves as a mirror. So this is our mirror. Then standing here to see ourselves, where are we going to appear? Here. Down. Good. So if my point tends to appear here, then our coordinate will be written the same, but its operations will change according to the nature of the plane we have drawn. So over here, which one is going to change? Y, and it's going to do what? Exactly. So you are now telling me the formula. I have not given you any formula. So the reflection in the y-axis or in the line y equal to 0 or x-axis has been given there. That is the formula now that we are going to obey whenever a question is given to us. So the original point given up there was xy. Mapping onto a new location, that also gives you another point, what? X what? Negative y. That is it. So that is the formula for reflection in the line y equal to 0 or x-axis. Are you okay? Let's also look at the other axis. Reflection in the line x equal to 0. That means in the what? Y-axis. Come and help us with the formula. Demonstrate on a graph and tell us what the formula would be like. Then come and write it down here for us. Are you done? Okay. So the same point, and he has used the y line as the mirror line to reflect to this side. That will give us the nature of what we have here to be affected. So we have the x to be negative at this side and y to be positive, and that gives us our formula. All right, so we have reflection in the x-axis formula, reflection in the y-axis formula. All right, so let's look at the other formulas that can be given to us. But the most familiar ones are these two that we just talked about. So let's look at the third one. Reflection in the line x equal to k. Or you can also say x minus k equal to 0. So our original point, so this one, we are not demonstrating it on the graph. But the rule says that whenever, so the k is a constant. So any number apart from 0, any number apart from what? 0. So start from 1, 2, and above. So whenever they ask you to reflect a given point in the line x equal to 1, x equal to 2, x equal to 5, the general rule says that you are going to get what? At the side of the x-axis, 2k minus x, then y. This is the rule. Okay, this is the rule. So you apply that constant given to you to also take effect of the x coordinates. And the rule says 2k minus x maintain the same y as it is in the question. Then also applies to, so let's reflect this to the y aspect as well. So y equal to k, or you can write this as y minus k equal to 0. And this one also the same. So if we are expressing the x coordinates in terms of that k, when they are also talking about the y, do the same thing at the y coordinates and maintain whatever x that you have there. So over here we have xy mapped to. So can you help me with the formula for y equal to k? Yes. So build on the x concept and use it for the y. Yes. Very good. Let's clap for him. Hey, the clapping is very boring. Let's clap for him. Thank you. So x, then we have 2k minus y. So this is a rule concerning reflection. Let us also talk about another rule. We also have y equal to kx. And the rule says that xy will map to 1 over ky kx. So we have another rule like this. We have lots of rules concerning reflection. Few of them are being used in our examinations, or most of the graph problem that we find it. Few of them are being used. Mostly the number one and number two are the fluent ones that we normally use. In the special cases, we add the number three to it, but the rest of them, you just have to know the rule and you apply it in the near future when you further your education. Let's also talk about the number six, the rule for number six, y equal to x. So this one, you can see that they have exchanged the position of y and x. So you just have to exchange their coordinates. So x, y will be mapped to y, x. Okay. So when you get a question like this, find the image of the point with the reflection on the line y equal to x. Then our rule says that if x, y is given to us, then our image will be y, x. Change the position of the coordinates. Okay, that is it. And the last one, number 7, y equal to negative x. So what will be the image? So x, y map to, very good, negative y, negative x. That is it. So copy these rules down. You might use it in the near future. And we'll start applying the rules using our examples. Let me give you 1 minute to finish writing, then continue. So let's continue with our first example. Can I clean the rules because the board is full? Okay. So get your graph books ready. All right, so let's look at this question under reflection. So we're going to use our graph book to answer this question. Using a scale of 2 centimeters to 1 unit, draw x and y axis for the interval x greater than or equal to 0 but less than or equal to 8 and y greater than or equal to -6 and less than or equal to 6. Then you plot the points given here A, B, C, and A, B, and C, and describe the triangle. Describing a triangle means after drawing, being able to name the triangle that you have been able to draw. Then find the equation of the point AC. Then you also draw the image of that given triangle that you have already. Let's follow what has been given for us to get a very nice graph. So from the scale, let's look at the scale and use it to draw the graph that we have given us. Now for the x-axis, instead you start from 0 to what? +8. We need to manage this graph, change the position of the y-axis so that we can have enough space for the positive side of the x. We'll come back to that one. And the y has all the positives and negatives. So that one. So let's try and manage this graph. So we are not going to divide the graph into 3 equal parts. Okay? Because of the nature of the range given to us for the x-axis. Do you get what I'm saying? Okay, so we need to move the y line to cover up some of the negative portions concerning the x-axis. Okay, so for the x-axis, we have this line, and we are not dealing with any negative in the x-axis. So let's try and close the negative side of the x-axis, so that the positive side will be in a suitable form for us to present our work. And the scale given to us is 2 centimeters to 1 unit. Every big box in our graph will be numbered in intervals of 1. Okay, so if you don't move the y-axis to close the negative side of the x, we are not going to get the counting for the y, for the x rather. Do we get it? So let's do that. Let's close it to this form. Only if you can get the 8. 1, 2, 3, 4, 5, 6, 7, 8. So even let's make one of the negative number appear. So let's bring it here. Make sure you draw a straight line. Don't do what I'm doing. Drawing piece line. The ruler is not favoring me. That's why. Alright, so we have here to be the y axis and here to be the x axis. So let's label the x axis. We have the midpoint to be 0. Then right after 0, let's bring a negative 1 there. Then let's write the rest of the positive values for the x-axis. 1, 2, 3, 4, 5, 6, 7, and 8. Let's also label the y-axis. So we have here to be 1, 2, 3, 4, 5, and 6. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Let's begin the plotting. Starting from A, 3, 1. Are you following? 3, 1. So we have 3 here, 1 positive. So we have it here. Then we have A to be 3, 1. Then B, 1, 1. So we have it here, 1, 1. That gives you B. Then C, 1, 1. I don't know where 1, 5 is. So someone come and help me. So come and plot the 1, 5 for me. Then continue. Thank you. Thank you. God bless you. You don't want bless, you don't say amen. Okay, so let's join our lines. Make sure you do the same. So there's our triangle. This is our triangle. Make sure you have the same triangle in your graph book. And look at what they are asking us to do. You finish plotting, then we also look at what they mean by describe. Yes. Any question? Calling. Somebody's calling. Okay, so let's look at the description here. So after I've been able to plot all our coordinates, they're asking us to do what? Describe our figure. That's the shape we have gotten. So with a technical eye, the other time I was telling you, can't figure it out though, but with what we have here, it looks like something. Well, so what type of triangle do we have here? Very good. You have done well. So we have, because of the uh, the heights that we have been able to drawn from this particular triangle. So we have it, but don't show the right angle triangle, the symbol inside, please. Don't show it here. So we are going to write it in the word description. So for the answer for I, you describe the triangle to be the triangle. So we have triangle ABC is right angle triangle. That is it. You have described it. Let's move on to the second question. I hope you understand why I've named this right angle triangle. Because of the common features we have identified on that triangle. Let's also look at the question here. Find the equation of is it a line or a point? It is a line because They have combined 2 points, and 2 points gives you what? A line. Good. So let's focus on the 2 point AC. So let's first write our points down. The A gives us 3, 1, and our C gives us 1, 5. So we need to apply the equation of a line by bringing out the general equation of a line. So the general equation of a line is defined as. So let's say it together. Ready, go. Very good. It means you can recall rules or formulas. You have done well. So this is the general equation of a straight line. General, accepted worldwide, everywhere you go. But you need to understand the names of the variables that have been used over here. Now let's look at something here. You can identify y1, x1. They are going to be replaced by our points, the coordinates that we are going to choose. Then you can also see our m, which mathematically we call it what? Gradients. So we need to find our gradients. Already the points are already there. You can choose any one of them to work with. But our gradient must what? Be found before we can make the equation meaningful. So let's first find the gradient. So our gradient m, so we have its gradient m is equal to dy dx, right? Difference in what? Y over difference in x. So that means y2 minus y1 over x2 minus x1. So where would our x1, x2, y2, y1 be found? We have two coordinates, but we are not going to do any biasing here. First come, first serve. So our first point will be named once. Our second point will be named 2. Simple. Is that fair? Is that fair? Okay. So we have here to be what? X1, Y1. Then X2, Y2. We are using this to complete the formula for gradients. Then our gradient will be determined. Can we continue? Okay. So we have here, now let's substitute what we have here into our gradient formula. So y2 is giving us what? 5. So we have 5 minus y1 is 1. All over 1 minus what? 3. So our answer will be what? 4 over. This one there is not a vector, it's a fraction. So you have to what? Simplify this further. And that will give you -2. So our gradient is -2. So we are going to substitute the variable m representing the gradient from our equation of a straight line by using the -2 that we've gotten right now. Then we apply one of the coordinates given to the equation, then our final equation will be determined. So let's continue from here. So let's rewrite the general equation of a straight line again. Y minus y1 equal to m will now be eliminated. We're going to substitute with what? The -2. Then x minus x1. Okay, so let's look at the points given to us here. We have 2 points. We have 2 points A and C. Point A and point C. You can choose any one of them. So let's say Joseph. Yes, Joseph. Joseph decide to choose point A. Okay. Then Abena here decide to choose point C. All against a common gradient, -2. At the end of the day, you are going to get the same equation. True or false? Let's verify. You can't say true without verifying. So, Joseph, come, Abena, come and show our work. You're working for us. So we have here, so you, Joseph, you are using point what? A. Abena, you are using point what? C. Come and do that. So Joseph, come and start. So the first one, when you are done, I will let Abena come and do her own. So you choose the point A against the gradient -2, find your equation, substitute appropriately, and work out to get your equation. You can write the final equation in a slope form. I hope you know slope form, whereby you make y the subject. Or you can equate everything to 0. That's the standard form. Are you okay? Okay. Oh, let me do a line. So you gave the equation to us in slope form. Abena, your own okay. Your own should be in slope form and standard form at the same time. Okay. Uh-huh. Oh, there's your point. Oh, give us the kind of equation you want, but we want to compare to Joseph's own. So you should rather give it in the slope form. If you can also write it in the standard form, fine. But I want it first in the slope form. Are you done? Look at the gradient. So, hello, I'm talking to Abena, please. Abena, look at the gradients. Check over Abena. Look at the gradients. The gradients. The gradients. The gradient. You can see Abena size like you. Okay, let me help you. Okay, this is supposed to be negative. This is correct. We'll write this again. Negative should be the right. Ah, it's negative. So here it's negative. So Abner is still working. Yeah, yeah. Okay. So this multiply this with this one. So positive. So check the other one. So minus and the other side. Okay, you it's okay. Let's visit the question and see how best we would know the details inside. Thank you. Let's look at the two equations. So we have the general equation of a straight line. Then we decide to work out with different what points using the same gradient. So we have the point 3, 1. The 3 for the x. So correct substitution. So let's see the expansion of the bracket. This will give you negative, this will give you positive. Okay. Then we have here to be, this is also correct. Alright, let's get the second one. So correct substitution, the points are 1, 5. So the 5 for y and 1 for, so we have this correct. Then let's look at the expansion. This is negative. This this is what? But it's positive 2 here. So is there any mistake? Okay. Then what again? Okay. Now this is where the mistake comes in. See, whenever you are working, sometimes some like you won't see clearly. Like sometimes I don't see clearly. Okay. And that happens to happen. So so let's make a correction here. So we make y the subject. So over here we have negative 5, right? Send it to the other side, it will become what? Positive 5. And that will give our constant to be positive 7. And we still have the same as what we have, right? Very good. So that tells you if you're able to determine the gradients, any of the two given points can be used to determine the equation of a straight line. Are you okay? You get the same equation. Let's continue the question. We are not done. We have not answered the I. So the third question is saying that draw the image of the triangle A prime, or let's say A1, so A prime, B prime, C prime, which is the image of the original triangle ABC. Then the rule under the reflection in the x-axis where A map to A1, B map to, or A map to A prime, B map to B prime, C map to C prime. Then also indicate clearly the coordinates of the image. So let's do the calculation for the images. Then we plot them. Then we are done with this question. Are you okay? So let me clean the question itself and do that in the middle. I hope you have the point already. You have the point there. So you can look at that one. So working with the third question. So the rule given is reflection in the x-axis. Is it x-axis? Okay. So let's take the rule. So x, y, okay. So x, y maps to n, x, x negative y. We are building on this rule to derive all the images for the 3 points. Starting with the first one, A. And A was what? 3, 1. So we have 3, 1. Mapping onto A prime to be what? Look at the format here and you to do the arrangement. 3 negative 1. That is it. B map to, so B is 1, 1. So map to B prime, that is 1. Thank you. And C is 1, 5. Also map to, okay, for this one here, you are coming to do all the plotting for me. So if I give you the marker, you plot the first one, you sit down. Then after the time we'll plot and somebody will come and draw the line. You draw the line in pieces. Somebody will draw a straight line, sit down. So all the lines are being drawn. Yes. Yes. Come and plot the image for A. Then plot the image for B. Madam, take it. Take it. Yes, C. So come and draw the image for C. So one after the other, when she is done, the second person, oh, come, where you are, it will take time before you get off. Thank you. Yo, so the second person should come for B. I hope you're okay over there. Okay. Oh, change the marker. Use the black marker. Clean it. Let me clean. Thank you. C. Who is coming for C? Thank you. Oh, okay. All right. So it is left with the drawing of the line. So connect A to B for me. A to B. Use my ruler. Don't use your free hand. Connect A to B. A to B. Don't go me. A to B. Come for it. Come for it. We are selling A to B. Come and join the line. Use my ruler. Then B to C. Take it. B to C. Okay. The next person to take the ruler. Is it complete? B to C. Yeah. Now to slap it A to C. Okay, A to C. A to C. Don't worry. A lot of questions are coming. Don't worry, a lot of questions are coming. A to C. A to C. Make sure the ruler is straight. Thank you. Now let's have something here in our diagram and also take notes on this. Okay. Open your eyes clear. Look at what we have here. We have coordinates, the image for coordinates A, B, and C. But you can see that when we were asked to do what? Indicate clearly the coordinate. That's what we have done. But when we are indicating the coordinates for any figure drawn, make sure you don't write inside that figure you have drawn. Okay? That's why you're using a pencil, so you can clean it and write it outside. So we can see from the triangle that we have here. Okay, so the coordinate B is found inside. That is not appropriate. And also the coordinate A2 is found inside. So you can see from the first one, everything is outside. So we have to just clean it and write it outside. So it was what? B, y negative 1, right? And this one is A prime. So that is it. Apart from that, where is the B? Oh, okay. Okay. Is that A or B? This is A, right? I wrote A and you are saying B. Which one? The prime. Oh, you have good eyes, so. And which one again? The A prime is here. Thank you. Uh-huh. For the first one that we done for the relation, that's the translation. That one, we first drew the first one, and its coordinate was outside. Then the second one that we also draw, the coordinates were also outside. Just that it entered the first one. That means the one that enters the first one, that coordinate wasn't for it. So it is different altogether. So if I draw something like this, so let me score the graph. This is the first one, and I have my coordinates labeled here, A, B, C. In case I will draw another one, and it ends here in the middle. So where would my coordinate here? Where would it be? It will be inside, but inside doesn't mean it is the one that we have drawn. Okay, are you playing? Thank you. So we have answered the question successfully. Now let's talk about rotation. Rotation. So we are going to do rotation. Can I clean the board? Okay. And you are going to derive the formula by yourself. I hope you know the formulas. Okay, so whether you know it or not, you are going to tell me the formula by using the Cartesian plane. So let me clean our coordinates and draw it again. to the normal form. So I'm dividing it into two equal parts. So rotation is also under rigid motion. So we have looked at translation and what? And what? Reflection. Now rotation. We are going to look at the formulas for rotation. Let's write the formula by ourselves. So always we are beginning our first coordinate from the quadrant that gives us positive coordinates, right? So that is what you can see from the graph board. Let's understand the meaning of rotation before we begin our experiment. What is rotation? What is rotation? Yes. What is rotation? You see, in this form of question, you can answer with scenario or direct definition. So any form of the answer is accepted. So scenario means creating a story or real life situation to explain the concept of what? Rotation. Or direct definition is also accepted. So which one are you giving to me? Yes. Moving about my own axis. Good. Into okay. So if I am sitting on the floor, then I use my buttocks as an axis, then be rolling on the floor, going around. So I am rotating on my own axis, and my axis is known as buttocks. Right? Good. Let's use the door. You open, you close. You move it from one direction to another direction. And the axis that you are talking about for the door, it will be the what? The hinges, right? Of the door. That is okay. So for me, it is about us, right? I can't rotate in any other form apart from that. Those children, that's what they have been doing. So that is the concept for rotation. That is the concept for rotation. All right, so let's apply this in the mathematical language, the rules, so that we'll be able to use to solve what? Problems relating to the direct questions or graph related questions. All right, let's look here. So we are rotating, okay? So this will be my ruler. So this is the ruler. When they ask you rotate the ruler, turn it upside what? Down. This is my ruler at the original position. Rotate the ruler, turn it what? Upside down. You continue to do that, so they ask you to stop. But let's look at the direction where we are going to perform this rotation concept. It is normally taken from the what? Anti-clockwise direction. Okay, from the opposite side, opposite reading of the what? The clock. So rotations are being taken from the anti-clockwise direction. So let's take the formula names, put up our experiments, and our formula should be derived and added to the names that we are going to put down. Are you okay? So we have first formula, rotation through 90 degrees anti-clockwise, or 270 degrees clockwise. So our formula will be SY, waiting for our result and add it to it. Let's come to the second one. Rotation through rotation through 180 degrees anti-clockwise, or half turn. So we explain why it is half turn. XY map to so and so. The last one, the next one is number 3. Rotation through 270 degrees anti-clockwise, or 90 degrees clockwise. So that one too, we have a form XY map to. Okay, so we also have the fourth one here. Rotation through, so rotation about points. Okay, about point AB other than the origin. Okay, so this one has 8 formats to talk about. So let's look at the first 3. Proof to the rules that we are going to apply to solve our problem, and the fourth one also be added. Let's come back to our XY line, or the Cartesian plane, and perform the activity. So we are talking about rotation, so let's do it together. Our point given is XY, and we are taking it from the anti-clockwise direction. That means from this direction. Are you okay? So if from this direction, then the immediate quadrant that you have here is your 90 degrees. Okay, so you have here to be called 90 degrees, and that direction is called what? Anti-clockwise. So 90 degrees anti-clockwise. Now you can see from the board that it has the other name 270 degrees clockwise. So if you also read the direction from the clockwise position, you are also going to read different degrees, but that degrees is being measured in the clockwise. Okay, so over here, taking it from the clockwise direction, this gives you the immediate first 90 degrees. Are you okay? Then we move on to 180 degrees. Then coming up to the position of the 90 degrees of the anti-clockwise, that also be generated as what? Is the accumulation of the 90 degrees that you have been moving. That will give you what? 270 degrees. Do you understand what I'm doing? So over here we have 270 degrees what? Clockwise. So I've given you these two names just for you to be aware that in a given question, when you are being asked to use the name, rotate through the given point 270 degrees clockwise. Don't raise your hand and say that we don't rotate through clockwise. They want you to know that 270 degrees clockwise, they are referring to the 90 degrees anti-clockwise. So use that appropriate formula and apply to get your image. Do you get it? All right, so let's continue with our naming. So if this place is 90 degrees anti-clockwise, it is also named as what? 270 degrees clockwise. Let's come to the second place here. Now over here, so we are adding up the clockwise and reducing the anti-clockwise as we are moving around. So this one gives you the anti-clockwise, and it is a what 180 what degrees anti-clockwise. The namings are very important so that whenever you are applying the formula, you be sure about the one that you are using. And let's come back to the clockwise direction. So when it is also taken from the clockwise direction, you have to know that this place is still 90. Coming to this place will give you another what? 180 again. Okay, so from the anti-clockwise we get 180. From the clockwise we still get what? 180. That is why we call it what? Where is this? Oh, I just wrote half. It is called what? Half turn. So even if you pass the anti-clockwise direction, to give you the same angle as you pass from the clockwise direction. So that is the half turn. Are you okay? Okay, so we have the name 180 degrees. So let me make it the half turn. So over here is half turn. Let's come to the last rotation. So over here, so the accumulation of the anti-clockwise. So if it is 180 plus 90 will give you what? 270 degrees anti-clockwise. And if it is coming from the clockwise direction, what will it be? 90 degrees clockwise. So in any other form that you'll be giving, you must be sure of the formula, and the formula is still the same. That's why over here I'm giving you two names, either 270 degrees anti-clockwise or 90 degrees clockwise. The formula is the same. Now what is the formula? Let's start our rotation. We have our namings there, so we need to apply our experiment, starting with the xy. Now, so my x is here, my y is here. Let's turn it upside down. Which one will come on top? At this place, right? Y, and x will be what? Down. All right. Let's finish all the rotation, then look at the operation added to them. Let's rotate this again. Which one will come up again? So we have x and y will come down. The last rotation, y. So y will come up, x will come down. Now, the operations at each of the quadrants will determine the nature of our image. Are you okay? Let's come to the first rotation. Now, at this point where it is 90 degrees anti-clockwise, we have the x-axis to be what? Negative. Look at where it is. Although you have not named it, so let me put here negative, positive, positive, negative. Everything that we'll write there are negatives or positive. So we have here to be what? Negative. So the x-axis at this particular quadrant gives us what? Negative. Then our y-axis at this quadrant gives us what? Positive. So as we have to apply the appropriate operation for the x and the y. But that doesn't mean I'm saying this x-axis is negative, so you are supposed to add negative to the x. No. You know the application of quadrants, so application of coordinates, rather, coordinates. The coordinates are being expressed as what? xy. Okay, so no matter the number that comes first, it is still for x. So if I write p hill and I ask you what is the x coordinate, it is what? P. So if I have yx and I still ask you what is the x coordinate, will you tell me x again? It is the first number, it is what? Y. So we are going to look at the first number is standing in for what? X. The second number is standing in for Y. Unfortunately, it has been the opposite way of their names, but you have to be vigilant and know that you are doing the right thing. Are you okay? So since our X axis is since our X axis, hello, can you hear me? Okay. So since our X axis is negative, we apply what? Negative to our first number, not to that X that you see there. Do you get it? Then what happens to the second number? The second number is for the y-axis and it is already positive, so don't add anything to it. Let's come to the second rotation. We have our 180 degrees anti-clockwise, right? And for that particular quadrant, all the two axes are negatives. You can see that. And with the first coordinate that you see is x. Whether it is x there or not, it is still representing what? X. But unfortunately, it is the x itself. So we have it to be what? Negative, negative y. So let's finish with the last one. Let's finish with the last one. We have the last rotation. Look at where it is now. So for this particular quadrant, we have the x to be positive. That means the first number should be positive. The second number should be what? Negative. So we have the second number to be negative. These are our formulas. Let's come and write them in place of their corresponding names. Starting from here. So rotation through 90 degrees anti-clockwise or 270 degrees clockwise is giving us not oval. Say it again. Negative yx. So we have here to be negative y positive x. So you have derived the formula, or I have derived it for you. I just guide you to get the formula right. Okay, so let's look at the second one. Let's do the second one. For the half turn, what is the formula related to the half turn? Negative x, negative y. And for the 270 degrees anti-clockwise, what is its formula? Y negative x. I hope you never forget this. Okay, that is nice. Now, also let's look at the fourth one. The fourth one goes with a condition. It doesn't have a specific rule. So let me explain the condition given to you. There is no specific rule relating to the first three rotation rules. Okay. So you see, from what we have done here, we were rotating from our own axis, and that axis is the point of origin, 0, 0. So the point is from the origin. This is the case when you have been asked to do rotation, and the point is not from the origin, but from different coordinates. Do you get this? What we just did now, it was from the point of origin. That is the axis we're standing on to do the rotation. But the fourth one is explaining if we are not using the point of origin. Let's say we have already given us the object hanging somewhere. So, and using this point as a rotation, which means we are getting away from our point of origin, using different coordinates as our new axis to do the rotation, right? Okay. Let me drink small water. Uh, all right, so now the rule says that, so just listen. Then when you are applying in our question, you really understand how it is being used. So first, the subtract, so just put it down. I'm reading, put it down so that you follow the rule and use it to answer questions under it. So first, under point number 4, okay, subtract the center of the rotation from the given point. Write it. Subtract the center of the rotation from the given point. Subtract the center of the rotation from the given point. And it goes with this expression. So with this point you've written, add this one to it. If, are you following? If a given point is xy and the center is given as AB, so the expression that says the subtract the center of the rotation from the given point is given as, that is, x minus a, y minus b. This is the expression. So as you have the point, given point named xy, and a center has been already been given in your question, subtract that center from the given point. Okay, that's the first rule. Let's move on to the second rule. Can we move on? Okay. So we have second rule. Apply the appropriate rotation formula. Write it. Apply the appropriate rotation formula. Apply the appropriate rotation formula. They will show, so don't add what I'm saying afterwards. They will surely give you the specific rotation formula, the name. Okay, although we are not rotating from the point of origin, they will still be giving the direction where the rotation should go. And this direction will come from any of these three. These three are always, they are standard. Okay, so although they are giving you the question in the fourth form, they will still give you the specific location you should move to. So what you do is, as they are giving you a point which is not from the origin, you have to subtract that point from the given, that center from the given point. You will surely get a result. That particular result you are going to derive or get. Apply the appropriate formula among the 1, 2, and 3 to 8. If it is to the 90 degrees anticlockwise, do that and get a new point or new coordinate. That's the meaning to the point number 2. That says apply the appropriate rotation formula. Then let's look at the point number 3, the final point. Add the results. Add the results to the center of the rotation. Add the result to the center of the rotation. Add the result to the center of the rotation. Add the result to the center of the rotation. Do you understand this point? So, after you subtract the center from the given point, you get a specific point, new point again. That specific point, you are going to apply the rotation direction to it. And you surely get a point again. That point that you got it after you have applied the formula will be your final answer. Are you okay? So when you get a question, we'll practice on this. And this expression to the explanation I've given you is that, so just take this one. So that is x minus a, y minus b will give you negative y then finally you have so this is the expression. You get the understanding better when you start with the example. Let's begin with the graph example. So keep the formulas in mind When we need them, you will call for me to apply. Are you okay? So let's write this question inside our graph then answer it. Yes. Okay. All right. Let's write the question down. Please keep quiet. I hope you are writing. right, so there's our question. So finish writing the question, then let's look at what the question is demanding us to. Can we start? Right fast. Just a minute more. Okay, let's start. So let me clean what we have on the board. Let's do it together. Are you ready? So using a scale of 2 centimeters to 2 units on both axes, so talking about the x and y axis. Every big box we are going to number with the intervals of 2, right? 2, 4, 6, and so on. With the given ranges here. So for x axis, start from -8 to +8, and the y axis start from -10 to what? +10. They indicate clearly all the coordinates, the vertices and the coordinates. Then of the triangle PQR with the following points, the vertices and the coordinate that you're going to also get. So let's do the first one. So the A and B. Let's draw our. So according to the range given to us, we need all the negatives and the positive um, portions from our given axis. That is for the x and for the y as well. So which means we need to divide the graph into two equal parts. So 1, 2, 3, 4, 5, 6, 7. Make sure you enclose all the points with arrows. So, then you label it OX and OY. Then your origin, you just write it there. Let's begin with the numbering of the axis. So let's start from the x-axis. So -8 to +8. And we are using the scale 2 centimeters to 2 units. So let's start with the positive side. Then for the y-axis from 2, 4, 6, 8, 10. -2, -4, -6, -8, -10. All right. Let's answer the question BI first. So we need to plot the vertices given to us. P, Q, and R. Are you following? Okay. So the coordinate for P is what? Negative. Okay, so in fact, -360 there, I can't see. Go and do it for me so that my eyes will be cleared. Thank you, sister. God bless you. In fact, stand there and let us give you all the points for you to plot for the P, Q, and R. Okay? Okay. She will come and draw the line for us. Yes, come. So, plot points P, -3, +6. You're not done. Don't put full stop there. Then the point Q. Give it to her. -1, +1. The next one. +4, +2. Why full stop? Okay, thank you. Let's clap for her. Let's clap for her. Yes, we need volunteers to come and draw the line. Joanna. Where is Joanna? Where is Joanna? Joanna. In fact, complete our triangle for us. From A to B, B to C, then close the other part. Okay, the first one to the second one, not A, B. P, Q. Yes. Please keep quiet. Should I hold this for you? Wow. No. Don't clap for her. She has done well, but don't clap for her. Don't clap for her. Do you know why? Do you know why? Who are technical eyes? Yes. She has leave one of the coordinates inside for me. But you have done well. Let me only clap for you. You have done well. Don't clap. Okay, so write it outside. What was the coordinate? So that is P, right? A scale. Negative 1, 1. Okay, so that is it. Let's continue with the image. Let's continue with the image. That is the second question. Oh, we have a lot to talk about here. So, triangle P prime, Q prime, R prime. With, oh, they have given you the coordinate too. Can you see that? No formula attached, just the coordinate. So why don't you plot it like that? Ah, so hallelujah. So we are going to plot this because it is already been given there. So P prime, sister, take it. Go and stand there, plot P, Q, and R primes for us. These are the coordinates we are plotting. It's off. Are you done? You want to draw? Okay, draw. What is saying? Are you done? Thank you. Shazan is saying mistake. Oh, can you see that? Okay. Do the writing. Oh, so let me write it before I play. All right. So that is it. You see, we have the third question here. The images under rotation through 180 degrees about the origin means anti-clockwise. Okay. Okay. Whereby P map to P2, Q map to Q2, and R map to R2. You have 5 minutes to do that one for me. Your time starts now. 2 minutes. You have 2 minutes. You have 2 minutes. Less than a minute. Prepare your answer. Going to put it on a board together. You must state it clearly. I mean, they have look at this. From the beginning, they said draw and label clearly all the vertices and the coordinates. Label clearly. And that is the B, taking effect to the I, and the I. Okay. So let's say our result. So we were being asked to solve the third one, right? We are supposed to use the particular formula, apply to get your images, then you plot them. So let's start beginning with the formula. Beginning with the formula. So someone should go and show working to get all the images for the P2, Q2, and R2. Then we'll also continue with the plotting. Rebecca. O2. Where is O2? Rebecca O2 Amokwado. Come here. Where is she? Where is she? Jessica O2. Hey, Jessica. Where is O2? Keep quiet. Better. It's okay. O2, your 202. Start from you. It's okay. So you are going to apply the formula to get all the images for us. Then you go and sit down. Don't go beyond that. Please write the name of the formula before you use the. Hey, don't use your hand. Take this. No. As you have stated the formula for us, find all the images for the 3 points. That's what I asked you. Thank you. Let's clap for her. Thank you, O2. So rotation through 180 degrees about the origin. Is a formula for it? Okay. So the points, you said what from P to, so where is P? -3, +6. Okay, so, okay, so the points are correct. Somebody is from Okada here. Come for the matter. Who is from Okada? Come for it, come for it. You have idea. You are just going to plot the code in that one. Come. Just plot. You won't join the lines. These are the points. Oh, but you must label the coordinates P2, Q2, R2. So look at this and plot it there. 3, -6. 3, -6. 3, -6. We are in our last hour of activity for this particular lesson. So surely very soon we'll go for break. Friday. Uh-huh. All the three. All the three. So P, Q, and R. Look at them all. Oh, sorry there. Has it eaten into another point? Still, let it be there. Which one? Cover the marker first. It will get dry. Which one? 1, -1, or yes, one. Where is the one -1? So where is one? Where is one? One. This is one. -1. It will appear here. Which one? Negative 4. No, negative. Negative 4, negative 2. So appear here. Negative 4, negative 2. Yes, yes. This negative 2, negative 4. Come here. It's R2. Thank you, thank you, thank you. Let's laugh for him. Let's laugh for him. Thank you, thank you. So where's the first one? But wait, the kill is what? 1, negative 1. So you have to rewrite the coordinates 1, negative 1 like this. And this one says negative 4, negative 3. Hey, it is 3, negative 6, sister. Why? 3, negative 6. All right, now we have our correct coordinates points over there. This is my 2. This is my 2. Which one? Mhm. It's not at 1. Yeah, this is a point. So this is a point. So that is 1, negative 1 here, right? Our what? Lines. Join the points for us. Can you see? Wait, this is P2, Q2, R2. So after drawing and the coordinate has been defined inside, try and clean it and rewrite it outside for us. So this one. So clean it. I'll look at it before when we write this one. Okay. Do you remember the coordinates? Okay. Very good. So we have gotten our third triangle. All right. Let's look at the last aspect of the question. Question C. Have you heard of single transformation before? Okay. Then let's do it together. So open your eyes and watch what we are coming to do. We have a relation here. Look at it carefully. We have triangle PQR being compared to the triangle P2, Q2 R2. Then the single transformation that they are talking about is the formula or rule that they have used to relate these two given triangles. Are you okay? The rule that they have been used to relate these two given triangles. So we have the first triangle PQR. Which format or which rule was being used to be given in the another triangle or in the image of that given triangle that they have indicated to be P2, Q2, R2. So the formula and the formulas that we are talking about, we do personally we don't know unless we prove something before we get to know the formula. Okay, and it can even come from reflection, it can come from rotation. Any formula that we have talked about can be one of them. Do you get it? So let's prove and see the formula that can be derived from the relation over here. So let's write the rule as it is. P triangle PQR onto triangle P2 Q2 R2. So we are going to use the points that we have already derived and relate onto each other. Okay, it's just like mapping. Okay, relate onto each other. So start from the main triangle, the coordinates for the P. So for P, it was given as what? The P was given as -3, 6. Map onto P. P what? Let's also look at the formula for P, the coordinate for P2. That is what? 3, -6. Good. Let's come to the second one, Q. The coordinate is -1, and the Q2 will be 1, -1. The next one, R, which is 4, 2, is being mapped to R2, which is what? -4, -2. Look at this relation on the board. Just compare what we have. So this is our analysis, okay? We are taking this to be our original point. Watch carefully. For us to get the formula, these are some of the deductions you must what? Do for you to know the exact formula being used. And even it is the name of the formula they want. That is a single transformation, okay? So we are going to make this as our original point xy map to, let's compare their relation. Watch here. From the points that we have been deriving here, see this. Look at the difference between the point P and point P2. We have the x to be, so how come the x -3 changes to +3? So what happened to it? Which means the formula that they use, x was negative. Is that true? Let's prove it with the second one as well. Then we have the same thing here. We will only compare the x, then come to the y, okay? Then this one too, the original point has changed to our new point. So we have the difference. So there is -1, and we have gotten what? 1 as what? The image. So which means x was what? Negative. And even this one tells us that x is positive, but over here x is what? So we are going to put negative to x. At the end of the day, to give you a specific formula, a rule. Okay? Let's come to the y. Let's start from here. So y is positive at the original point, but y is negative at the image. So y is negative, right? And the same thing applies to the second one, positive at the original point and negative at the image. So y is also negative. The same thing. So y is also what? Negative. So what is the name of this rule? What is the name of this rule? Uh-huh. Simple. So as you have been able to compare their differences, you should be able to put them into a relation form, XY relation form. Then when you are being able to do this, then you can therefore say that. They said what? What single transformation? So you are going to say that the single transformation, the single transformation is the rotation through half turn. So I will decide and I will choose the name half turn. Are you okay? It is the name of the formula they want. But before you get the name of the formula, okay, okay, ask a question. Stand up. Your friends say they can't hear. Let me give you my.
Okay, so I'm saying that since x, y maps to negative x, negative y, can you say multiplication by scale factor negative 1?
Are you okay? Very good. All right. So that brings us to the end of this particular question. Okay, this particular question. Are you okay? What are you expecting? Okay, so let's move on to enlarge enlargement. And enlargement. So we are going to look at the enlargement from the origin. Okay, enlargement from the origin. So whenever there is a given coordinates and you want us to perform a given transformation to this coordinate, they can also be given a specific scale factor so that we can have its corresponding image. And that particular scale factor will lead to the concept enlargement. Okay, let's look at um, a sketch on how enlargement looks like. Then we apply this in our question that we'll be solving. So imagine we have, let me give out any point out there to do the sketch. enlargement from the origin. So let our given point be x, 2, 1, y, 4, 3, and z, 3, 5, with scale factor positive 2. Let's watch something here. So as our sister was talking about scale factor, we got into the concept of enlargement. So it has the formula. So the formula for enlargement, that is xy mapped to the scale factor multiplied against the given point over here. So we have the scale factor here. So if you want to get the image using enlargement principle, the scale factor given to you will be used to multiply our given point. Then our images will be derived from there. Let's do that quickly, then we'll do the sketch. So we have our first point to be x, that is 2, 1. Then our applying the scale factor, which is 2 against 2, 1, will give you the image of x. The image of x, that will be what? When you apply the scale factor to the original point, what will be the image? 4, 2. So that means we use the scale factor to multiply through, right? We don't use to add. We used to do what? Multiply through. Good. Let's move on to the y and the z. So the y has 4, 3 mapped to 2 multiply 4, 3, giving us the image of y to be 8, 6. And the last one, 3, 5, giving us a scale factor of 2, 3, 5, and the image will become 6 what? 10. Good. Let's put this into sketch from the point of origin. Okay. Now over here we are just sketching it. So we have our y and our x and our origin. Okay. So let's label this. The highest number on the x-axis is what? Just look at it and tell me. The highest number on the x-axis and the highest number on the y-axis. Positives, right? Okay, so we have here to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. So we have our scale here. Let's plot the first point. The x is 2, 1, right? So this is 2. 2, 1 will be here. This is a sketch. You don't want to do it on a graph. So 2, 1, that is our x. Just write the x. Then we have the second one, y. 4, 3. So we have 4, 3. 4 against 3 here. Okay. Then we have here to be y. And the last one, 3, 5. 3, 5 will be here. And that is our z. So you have to form a triangle with this. Okay. And also plot the image. Let's do the image. 4, 2, 4, 2. Here, 4, 2. And that is x prime. Then 8, 6, 8, 6, 8, 6. Down. Is it okay? Okay, so we have it to be y prime. Then 6, 10, 6, 10, 6, 10. Right? Like here, and that is z prime. And you are going to also complete the triangle for that one. Good. Look at what you are going to do. We are going to demonstrate the enlargement from the point of origin. Okay? So after plotting everything, you are going to extend the lines from the point of origin to their corresponding vertices in the from the original point to their what? Enlargement point. Okay, their images. So look at. So we have x mapped to what? X prime from the point of origin. So everything will be drawn from the origin through the point. So that is for x. Let's do same for y. This is y, this is y. So also match up from the point of origin. I said this is not skill school. It is not under skill. So we'll try to manage. Okay. Okay. So which means the point has to be here rather. So okay, then our set. It has to be up rather. Say this one. It has to be up this one. So it has to be up. So let's do that. Okay. So we can extend the lines. So we have just demonstrated the enlargement from the point of origin. So after you draw the original point and its corresponding image, draw a straight line from the origin throughout the corresponding length. From x to x1, you just extend the line from y to y1, from z to z1. And that is the meaning of the enlargement. Yes. It depends on the kind of question you are going to be giving. Okay. So as they have stated here, from the point of origin, enlarge this from the point of origin. When you finish drawing our triangle, then you extend the lines from the point of origin. Do you get it? All right. So this is just a sketch to demonstrate that. Now let's look at, so you know the formula, right? Let me complete this formula. I've even used to find the coordinates for these points. So what strategy did we use? We multiply the k against the x and the y, right? So this one will give you kx over what? I said over. Kx and what? Ky. Good. And this is the formula for enlargement or using the scale factor. All right. Let's also look at the one aspect of the enlargement. Enlargement from any points other than the origin. So this time, you see, we have demonstrated the enlargement from the point of origin. We have another one that also talks about enlargement from any point other than the origin, which means that enlargement did not take place from the origin. What format are we going to use to draw our enlargement? Do you get it? So let's look at that one. Can I clean this? Okay, so let me give you the steps and use the question for it. So write the heading for it. Enlargement from any point AB. So any point that given point has been named as AB. So any point. So this point is serving as the origin, the new origin. This one. From the points that they are giving you as a coordinate xy. But for this one, it is representing the origin. Okay. Okay. So first, before you this, write this uh, statement, then you add this to it. So first, this is what you do. Subtract is similar to the one we talked about for the rotation. Okay, it's similar, the same thing. So subtract the first. This was talking about enlargement, so still write this. Subtract AB. AB is the new point. So subtract AB in a coordinate form. So like what I've written over there. Subtract AB from the point, from the original point. And that's what I've demonstrated here. So you subtract the new center from the original point like this. Okay? Alright. Then the second point, enlarge with the given scale factor. So for the rotation one that we talked about, it was what? Enlarge with the given what? For the rotation, it's the same format, but this one is talking about the scale factor. Then the rotation one talks about the appropriate formula that they will mention in the question. Yes. So that is it. So enlarge with the given scale factor. Okay. And that will be So after you have gotten this the new expression. If they are supposed to be numbers, you get exact values, right? So we have here to be, so the answer that you are going to get, so that's the point number two expression, write this attached to it. This is referred to as our answer, and that is x minus a, y minus b, mapped to the scale factor will multiply the x minus a and y minus b. There must be values when given in the question, and that will be in the last part will be add the result to AB again. So if you have example on this, which means you can apply the same thing for the rotation. So let's get example on this right now. So the third point says add the results to AB. So this becomes our result. So we have the third point. So that is, the result is k kx minus a, then ky minus a being added to a and b. This gives the result. Do you understand this expression? So the first we do the subtraction. Mhm. Which one? Yes, y minus b. Very good. See how good I is. So that is it. So this is the expression that you're going to use. Let's use this example to finalize this. Find the image of, so let me write it down. For example, to this. All right, let's go over this one after the other by using the rule that we have just discussed. So you can see the point, the center that they have given to us in the question is not from the origin. So what we are supposed to do is they said find the image of point P. There's the XY that we are talking about. Under the enlargements, at first, this one is from the origin, but this one is from a given point, 2, 5. Find it. And with the scale factor, what? 2. We are finding the image. So first, what do? Subtract the center of the enlargement from the points. So let's do that. We have our point 1, 2, 1, 2 minus 2, 5. And that will give us 1 minus 2, 2 minus 5. And the answer will be good. Then what is the second point? The answer that you have gotten here, apply the scale factor to it. It will give you another result, which is we have our new answer to be 1, -1, -5, -3, -3. Then the scale factor is +2, so 2 multiplying the coordinate, giving us -2, -6. What next? The answer I have gotten here, you add it back to the center. Then let's do the final. So therefore we have -2, -6 plus 2, 5, which is equal to the answer 0, negative 1. This is the final answer. So when you go through this procedure, you are going to get the right coordinate they are asking for. So this is when it is not from the center. It is not from the origin. So if it is not from the origin, then that giving the new center giving must operate using this strategy to get your correct image. Do you get it? Good. All right. In a few minutes, we're going for break. But let's also talk about, we have talked about a single transformation from a previous question, right? So let's have one more example on single transformation. This one, you are going to help me to get the formula, okay, because you have idea on this one. We are not plotting. We're just giving as a question, only a question on single transformation. So it's not a graph way. So now you understand single transformation, right? You understand single transformation. Okay, so let's look at the question. Describe the single transformation which maps triangle ABC onto triangle A prime, B prime, C prime, where A map to A prime, B map to B prime, and C map to C prime. So the coordinates has to represent them. So let me change them into coordinates so that we will not write the coordinates again. So where A, the coordinate given 1, 2, map to A prime, the coordinate given negative 1, 2. Then come to B. B, the coordinate is 4, 4. Map to B prime, the coordinate is negative 4, 4. Then C, the coordinate is 3, 7. Then C prime, the coordinate is negative 3, 7. Okay, since you have idea on single transformation, I hope you have idea on single transformation. Hello, very good. Use 5 minutes to work on this by yourself. Then after that, we'll talk about it. So you can. I will not repeat my word again. So 5 minutes. Start work. Is that what? Just so after that there will be presentation. So prepare yourself. As you are working, you shouldn't do what? Talk. So keep quiet and work. Give 5 minutes. Then you continue. Start. So if you go for break, try and change. Okay. These are the types you can change. Okay. Fine, fine. Okay. What's the question? Yes. The 5 minutes has ended. So let's see to it. Continue. So I'll let you count. 1 minute to stop work. So let's prepare our answers and represent them. So first, I'm going to write these two relations in terms of mapping, like what we did the first one. Then compare and write it in the form of formula before the single transformation will be written in statement. Okay, so we are going to do it one after the other. Okay, okay. So who's going to first? Just go and do the mapping. So it is there A map to A1. So just go and do that A map to A1 with the coordinates being written. Then we'll discard it. So Annabelle, don't worry. Everybody will come to the board. See, we have a lot to learn. So all of you come to the board. Don't worry. So use this space. Thank you. This is what Jane. Is it Jane? Uh, is it C prime? Oh, okay. C prime and this is C. Okay. All right. So we have the. Where is the cover? Where is the cover? The cover, oh, Deborah. Is it Deborah? No, the cover, the cover. Where is it? Missing. The cover is missing. Bring it here. Thank you. Thank you. Deborah, let's go. Take it. You know what to do. Come. So you are going to, this is what you are coming to do. Look at the difference between the X and the Y and being able to write it in terms of XY relation. Do you get it? So you just look at the difference and write it in terms of XY relation. Then we'll look at the name of the formula that is being given to that particular XY relation given to us. Are you okay? So do that for us. Magician. How did you know? Huh? You have done it over there before. Oh, okay, it is true. Thank you very much. Let's clap for him. Did not waste time at all. Okay, now it's left with the name. The name of this, the name of this relation. The name. Okay, okay. Come and write the name. Nobody should tell her. Oh. Nobody should tell her the name. Yes. Oh, I'll come to the back. Those are the back. Guess center is there. Okay, okay. Don't worry. What is that? Reflection in the line y equal to 0. That's x-axis. Is it true? It's not true. The angel of the Lord just told you that it's not true. Oh, it's true. My angel is lying. Eh? Is it true? So the whole class, what formula is this? What relation is this? Yes. That is in the y-axis. Are you okay? Thank you. Well, you have done well by even giving us a clue that it is under reflection. I was even thinking rotation. So thank you. So let's write this. Let's write this in the single transformation form. So they said describe the single transformation. So you have to state it in a short sentence. So therefore, the single transformation. Therefore, the single transformation is reflection in the x-axis, in the y-axis. Yeah. So that is it. You can also say reflection in the line x equal to 0. Let's look at, so if you look at our last question, I think to give us a lot of time for us to, so let's use a few minutes here to do revision. You have a few minutes, less than 5 minutes to go for break. So let's do revision on this. For non-cemetery, where they bury the dead body. Cemetery, cemetery, right? Yes. Cemetery, cemetery. Okay, rotational cemetery. What is it about? What is it about rotational cemetery? Mm-hmm. Rotational cemetery. You said, so rotational symmetry. What is it about? Hmm? So the number of times you are going to rotate a given plane figure, that will give us the same shape. Okay? The number of times that you are going to rotate a given plane figure, that will give us the same shape. It's what we call it as what? Rotational symmetry. So we have to count the number of the rotations that we have been doing for us to get what? The same shape. So this one is just a note. So we have polygons and their rotational symmetry. So polygons, they are the plane closed figures with straight lines. So the smallest polygon has 3 sides, and that is what? Triangle. Then it goes like that. So let's look at the rotational symmetry for the following polygons. Then we break for some time. So we can talk about square, rectangle, the rhombus, kite, trapezium, then the types of the triangles. We have equilateral triangle, we have the isosceles triangle, and we have the scalene triangle. Alright, so let me change the line here. And let me see. So let's quickly fill this thing to go for break. So this is just a note. The number of times we skip it, we rotate a triangle to get the same shape will be 4. Okay. Then the square, the rectangle will be 2. The rhombus will be 2. The kite will be 1. The trapezium will be 1. The equilateral triangle will be 3, and the rest will be 1s. So you study this, then also put this into practice. When you have that particular plane figure or shape, then you do the rotation and see whether the number of the rotational symmetry is true. Okay. Yeah, I always like proving. You have to prove to understand, so that when you understand, it always stays. Do you get it? All right. So we are officially breaking for this activity, and we are breaking now. Thank you. Hello. We have now resumed from the break. We have resumed from break. Let's continue with our lesson. I hope you are okay. That's good. So we are going to look at polynomial functions. We are going to look at polynomial functions. Polynomial functions. So we have different types of polynomial functions. Can you hear me? We have different types of polynomial functions. So I'm going to describe each of the type of these polynomial functions and how we can represent them appropriately when the questions are given. So first, we are going to look at linear functions. Linear functions. Hello, take this wrapper for me. So how do we express a linear function? How do we express a linear function? Give your ear to me, please. How do we express a linear function? Or what do we see on a linear function? What makes a given function to be called a linear function? Yes, who can say something about a linear function? Then we'll proceed from there. How do we describe or classify a linear function? Yes. The highest degree of the variable in question is 1. That is good. So we have here to be the highest degree of the variable is 1. All right. So that means the variable can be in any form, right? Is it only restricted to x, x? So it can be y, a, b, c, whatever, right? Okay. So let's express linear functions. So for example, we can have a function f of x equal to 2x plus 1. This is a type of a linear function. As our brother said, the highest power of the variable x should be 1. So if it is like that now, then this one is also a linear function. And since we are talking about function, we need to define it with a function notation. Okay? So this is a kind of a function notation. We have the notation describing f of x. And f of x is also being described as what? Y, right? But in terms of function, you make it to be f of x equal to the relation given to you, 2x plus 1. So the highest power of this variable is what? 1. Let's also look at another function. We have f of x is equal to 4x minus 3. This is also a linear function because the highest power of the variable here is also 1. So that is it. Now we can also be given to graph a linear function. We are not graphing now, but if there is a linear function and its relative range is for you to graph, this will be the nature of the graph. So we have the graph. The linear function at the end of the day, when we plot the coordinates on a graph and join the coordinates with a straight line, we are going to get a straight line in the graph, right? But there will be a direction of this straight line that we are going to draw in the graph. And the direction depends on the coefficients of the variable. Are you here with us? The direction depends on the coefficients of the variable. And the coefficient of the variable for the first one is what? Is what? The coefficient of the first function there that you have over there is what? 2. And the coefficient of the second function there is what? 4. So that's the coefficient I'm talking about. So if the coefficient is positive, so let's make the function to be f of x equal to ax plus b. F of x equal to ax plus b. So if in this function a is positive, or we can say that a is greater than 0. So if the coefficient of the given function is positive, the direction of our function being drawn will come from different direction, this particular direction. Okay, from the left to the right, and that's how the graph will look like. And when we come to this direction, we are going to say that when the coefficient is negative, or when a is less than 0. We are just describing the nature of a linear function. Are you here? Okay. So let's move on to the second type of the polynomial function. That is quadratic. Quadratic functions. Quadratic functions. Okay, so let's also talk about the quadratic function. We have described its part in the lesson that we just studied. What was the topic to that lesson? Algebraic expression. Yes, so we have a knowledge on quadratic function. So what is a quadratic function? Since you have been able to describe a linear function, then let's also use the same criteria to also get the quadratic function. So let's look at the quadratic function. What is its property? Its characteristic? How can you describe quadratic? Yes. So thank you very much, sister. So he just said that the highest degree of our given variable should be what? 2. So it is expressed as, we have, since it's a function, we start with f of x being equal to ax squared plus bx plus c. So this is the form of the quadratic function. Only if, hello, only if a is not equal to what? 0. If a is equal to 0, what will happen? What will happen? If you know, don't say it yourself, just let us know. If a is equal to 0, what will happen? Yes, you are going to get back linear function. So if you want to maintain it to be in a quadratic, then our coefficient of the highest power shouldn't be 0. Do you get this? All right. Now let's describe how the function will look like when we graph this particular type of function. So a function has a maximum when the coefficient is less than 0. So let's put this one down. So it has a maximum when the coefficient of x is less than 0. So let's put it in that way. When the coefficient of x is less than 0, then it has what? A maximum. So in the other way around, when it has a minimum, it has a minimum when the coefficient of the x is greater than 0. Are you listening? So we are describing a quadratic function when it is being drawn. You know the direction that it should have. Now let's look at this. How we can graph a quadratic function. So we have just talked about linear function, quadratic function. The polynomial function has been reserved. Let's fully talk about quadratic function. Then we go to what? Polynomial what? Function. I hope you are listening. So we just talked about something called maximum and minimum. Keep it in mind. I'll be asking you often. Okay. So graphs of a quadratic function. Graphs of a quadratic function. Now let's look at the general expression for a quadratic function again. F of x is equal to ax squared plus bx plus c. We are going to look at how we can graph a quadratic function. Pay attention to what we are doing, please. So if you want to graph a quadratic function, you need to know your maximum or minimum. You need to know the point at which the curve would turn. Okay? Then also you need to know your x and y intercepts. Are you with us? So we are going to demonstrate the basic formula that we'll be applying throughout our examples. So we have different ways of graphing quadratic function. Now we are going to prove what we have here into a major formula that we'll be using to solve problems. So we are going to talk about completing the square for the general quadratic function. So this is the general quadratic function. And we are going to look at how we can apply completing the square to this quadratic function. And all of us are going to cooperate, write what we are coming to do. Okay, let your attention be here. So let's begin. So the function is being defined as ax squared plus bx plus c by using completing of squares. So this one is not equation. Okay, this is just a function. So the completion of square will be worked within the function. We are not going to equate it to any number like zero or whatever or any constant. Okay, and we are working throughout our given variables, the functions. So first of all, we have the function to be f of x equal to, we are beginning the strategy for the completion of square. Okay, so f of x equal to ax squared plus bx plus c. If you are asked to complete the square for a given function, always make sure that the coefficient of the highest power comes to unity or 1. Make sure the coefficient of the highest power becomes 1. In this case, the coefficient of the highest power is a, which is, it can be of any number. So we need to make sure that particular coefficient a that we see there is being taken out. Okay, so when we take it out, it also affects the other terms in our function. Okay, are you following? So we are going to make sure the coefficient of the highest power to become 1. This time it is a. So how will we make it to become 1? How will we make it to become 1? So we are applying a factor principle. Okay, so we are going to take the a as a factor, and it will also affect the other terms. So let's take this. We have f of x being equal to, then we factor this out. Take the a as a factor out of our bracket. Okay, then we are going to have x squared plus, now you can see that the second term and the third term does not have any variable a attached to them, but we have forced ourselves to factorize this particular expression using a. In this case, we are going to apply the a to the second term and the third term. That still makes up the original function for us. Do you get it? So we have here to be, so x squared plus b over a x. Okay? If you have the person, you ask, plus c over a. So this is what we have now. So we have a taken out from this particular function. Then it will be expressed as x squared plus b over ax plus c over a. Then what next? We are trying to complete the square. Okay? We are not finding the root of the function over there. Now the next step is we should divide the second term by 2. Okay? You divide the second term by 2. Then the result you are going to get, you find the square, you add it to the same function and subtract with 8 squared. So let's perform this activity here. We have here to be, so we will keep writing the function name f of x, then a outside, we have here to be x squared, then divide the second term by I said we should divide the second term by what is distracting you? Who? What is distracting you? Nothing. So focus. Okay, so what are you going to do for the second term? By the coefficient of x squared. You have done that already. That's what you have done here. We have divided the second term and the third term by the coefficients of the what? The x squared. Then what next? Divide which one by 2? The coefficient of x by 2. Good. So I'm going to get what? B over what? 2ax. Then what do we do? You add and subtract the squared from the same function. Are you okay? So we have here, so plus b over 2a squared minus b over 2a squared. Then we have the constant there, plus what? C over a. So please follow what we are doing. So let's continue from here. Now we have gotten our perfect square from our expression here, right? So the function says f of x is equal to a. All right, so let's put out the perfect square over here. So we have x squared to go with what? B over 2a squared, and that makes the perfect square. We are going to get x plus b over 2a all squared. Now let's also work out this and write it together. So we are going to get minus b squared over 2a plus over what? 4a squared. 4a squared plus c over a. So let's continue. F of x. Alright, so let's try and bring this together. So we have x plus b over 2a squared. Then this one will give you what? The LCM for this one, this fraction here will be 4a squared, right? So what will be the numerator expression? So 4a squared for the denominator. What will be the numerator? Okay. So b squared plus 4ac. Okay. So we have what here? We have what? A here. This is multiplying everything in the bracket. Are you aware? Good. So this A will be given to the first what? Term in the bracket. It will the same. It will also be given to what? The second term. So which is the second term has a squared, and its part will what? Cancel the a over e. Do you get it? Now you're going to get f of x being equal to a into bracket x plus b over 2a squared. Then minus b squared minus 4ac. This plus 4ac all over what? 4a. Alright. So look at this expression. We have been able to use completing of square to derive a particular formula that we are going to be talked about on how it will describe a given function. Right. Now let's describe this formula. So from what we have here, you see we have this negative sign affecting the second fraction. Okay. So we are going to replace this by or maintains how it is. What should we do? if you put brackets around it, you are going to make it to be what? Negative. Do you get it? So let's put brackets around it, and it's going to be negative. The brackets will affect the numerator and the denominator. Now let's use different variables to represent what we have here. So we are going to say that we are going to let D represent B over 2A, and let K represent negative B squared minus 4AC over 4A. Yes. Yes. Which one? Which one? This one. Mhm. The negative is it's not affecting C on A. Okay, so this is what we have here. It's not affecting. But when you see the negative is direct close to our function, our expression here, right? And immediate to put equal to around our given fraction, it will directly multiply what is inside. Okay, try and rewrite or try and remove the bracket. When you remove the bracket, you are going to get here to be plus again. If the bracket comes, then it will be minus. Do you get it? It means the same. Or do you have any different answer that when the bracket is removed? Mm. And also bear in mind that this fraction b squared minus 4a plus 4ac all over 4a is one common fraction. So if one part of it is negative, the whole fraction is negative. Are you aware? So let's continue with our notations that we have labeled here. So therefore, this relation that we have described here will be reduced by replacing b over 2a by what? D. Okay? And replacing all these expression by what? K. Okay? So let's redefine what we have here. Let's come to this side. So in this case, our function is going to be f of x equal to a multiplied by x plus d squared plus k. Hello? So f of x is equal to what? A multiplied by, into bracket, x plus d all squared plus k. So what is d? D is b over 2a, right? D is equal to what? B over 2a. And what is k? K gives you this function. And this function determines either the function we are dealing with is maximum or minimum. If it is maximum, then the coefficient of the given quadratic function determines. So what criteria do we use to describe a function is minimum or maximum? I just put it down here before I clean the board. What function do you determine whether a given quadratic function is minimum or maximum? What do you what do you find in the quadratic function that you determine whether the function you will draw is minimum or maximum? The coefficient of what? X squared. And what does it tell us? When it is negative, we have what? Maximum. And when it is, we have what? Minimum. And this expression still works for either maximum or minimum. So if it is maximum, the same formula. If it is minimum, the same formula. But we have to what? Write describe the nature of the function, whether it is maximum or minimum, but the same what formula. And what is the use of the b over 2a? What does it describe? The b over 2a, the representative of the d, that is being used as the b over 2a. What does it describe in our given function? The what? Turning point. Okay, our turning point. That is being given as a formula b over 2a. So in most of the questions, you'll be asked to express your given function in this form. So the only way you can do to get this particular function is by using completing the square. Are you okay? I hope everyone know how to complete the square, whether in a function form or in an equation form. Hmm? Hello. So, so when we get to the solution of quadratic function, we also look at the completing the square again. Okay. So just um, concentrate and let's move on. So we have here the description has already been said. Now let's look at the nature of the function. So what's here? In case we have a given quadratic function with a corresponding range, okay, or that is the intercepts for us to plot, and also being able to get a turning point. This is how the function will look like when the coefficient of x squared is what? Positive. The function will do what? You face upwards, right? When the coefficient of x is negative, the function will do what? Face downwards. In fact, when you get the question in terms of the function for you to plot, the nature will come by itself when you use the right formula to work out. And our turning points here, we have our turning points at this side. And the turning point is given by the formula x is equal to what? B over 2a. This one too has the same turning point at this side. X is equal to what? B over 2a. Okay? So you must try and recall some formulas down so that it will help us to use to solve questions, related questions that will be given to us. Are you okay? Okay. So we have a question here. Finding maximum and minimum values of quadratic function. So let's look at these examples. So we are going to look at different ways on how we can find the minimum and maximum values of quadratic functions. So we are going to talk about completing the square. That's the first method. We will also talk about using the quadratic formula. That is popularly known as what? Almighty formula. All right. So let's go over the completing of square. So we are using the first method, completing of square. Let's look at these examples under completing the square. Let's look at how we can use it from the beginning. We use the general formula for the quadratic function to express ourselves in terms of completing the square. So at the end of completing the square for any given function, this is what you must expect. You are supposed to get something like this. Okay? Okay? Then they are asking for the maximum value. The maximum value of this given function. The minimum value of this given function, because the coefficient is positive, so it must be minimum. So the minimum value of this given function, and these are the representations over there. The d over there represents what? The value of x, which what? Okay, or the turning point. So after expressing our function to look like what we have there, whatever that we have for the representation of the d, that is the point at which the x occurred. Then you just look at that and quote it. Then whatever we have representing the k is our minimum. So now what we need to do is to complete the square. When we are done, the answers will just come. So if you don't get the concept of the completing of square, then pay maximum attention to this. Are you okay? Okay. Which one? Okay. So let's do this correction. So let's complete the square from this side. So our given function is f of x equal to 3x squared minus 2x plus 1. So let's do it together. This is not in the form of equation that you're going to equate it to any given number, right? So we are going to complete the square within the same function. So let's look at the procedures. First of all, what do we have to do? What is our first method or first thing we have to do when we are considering completing the square in any function? So we have to make the coefficient of x to be what? X squared to be what? 1. And over here we have the coefficient of the x squared to be So what do we have? What do we have to do for the x squared coefficient to become 1? Factorization. So we have to factor the 3 out. So let's do this. So 3 will be factored out. Then we have, let's write the rest of the expression. You see, this 3 over here does not have any relation with the second and the third term. So if it has been factored out, and it should also be given to the second and the third term as well. Do you get it? Okay, so let's do that. We have, now this one has remained x squared minus 2 over 3x, then plus 1 over 3. Good. So we are taking it from there. So those who don't understand, you're getting it small, small. So follow up. Let's continue. So f of x will be equal to 3 being taken out. The 3 will just be out. So we are done. Okay, and see which number is also going to cancel that 3 out. Now let's focus on what we have in our brackets. So concerning the concept of completing the square, what we have to do is the middle term that we have over there should be divided by what? And its result will be given. So you are going to square it and add it and subtract it to the same function. That does not change the nature of the function. You know that. Okay. So over here we have x squared minus. So when you divide this by 2, what are you going to get? What are you going to get? Initially, you are supposed to get 2 over what? 6. So you deduce this to simplest form, and it will be 1 over 3. Good. X. Let's continue. Now, before you write the other third one, you have to do the addition of x squared and the subtraction of x squared before you add up the third expression over there. Okay. So what? So we are going to add what we have here. 1. Remember, it is negative. Although we are adding, but the number that we are using is negative. So we are going to join the negative. Okay, the question again. Hello, hello. Uh-huh. Which term? Yes, we need to write the term. So that term will be 2 over 3. Then we add a subtract. Let me reduce the handwriting so that everything will go there. So we have here to be negative 1 over 3 squared, then minus negative 1 over 3 squared, then plus 1 over 3, then we close the bracket. Can you see? Now we can write the pepper square from what we had. So let's write the pepper square. Combination of this, so x squared to this one, right? So what will be the arrangement? Uh-huh. Mm-hmm. So we are going to take it as x minus 1 over 3 all squared. Then let's work this one out. So negative, this will be 1 over what? 9, right? Okay. Plus 1 over 3. So f of x will be equal to 3 into bracket x minus 1 over 3 squared. Then use the calculator, get me the answer to this fraction, 1 over 9 plus. Do it negative 1 over 9 plus 1 over 3. What is the answer? Positive or negative? Okay, so positive, positive 2 over 9. Good. That's our result that when we add these two fractions, we are going to get. What's next? Now we are going to look at the common factor that is being taken out now. It's going to be apportioned or given to the terms in our brackets, one after the other. I hope the understanding is coming small, small. Good. So let's give this, so that we have two terms here. One first term and the second term. So this three will be given to the first one, which will be 3 multiplying x minus 1 over 3 squared. Now, when this 3 is being given to the second one, we are going to do cancellation, right? The 3 will cancel the 9. And what are you going to get for the denominator? It will be what? 2 over 3. Now, let's compare what we have here to the general form that we derived the quadratic function. This one. Okay? So let me ask you, what is d in our new answer? What is d? D is what? Negative 1 on 3. Then what is k? So let's answer the question then. So the question is saying that what is the maximum value? So let's continue from here. Therefore, the minimum value is equal to, from what we have here, it is what? It is what? 2 on 2 over 3, right? Good. Then the value at which x occurs. So you have to equate this to 0, okay? Equate this to 0. Don't just record what you have here to be negative 1 over 3. Equate it to 0. So you are going to say that x occur at x minus 1 over 3 equal to 0. So therefore, x is equal to what? X is equal to what? Hello? X is equal to what? 1 over 3. So x occur at 1 over what? Are you following? So if I give you one, can you solve? Okay. Before I give you one, let's look at the other method. So this one talks about completing the square. Okay. Now also let's look at using the general formula, quadratic formula. That is the almighty formula. Or okay, not the almighty formula to be precise. Let's use the formula we derived from the beginning. So this time, let's say we don't want to go through the steps for the completing the square, but we know the definition for g and k, right? So let's state that definition again and use it to answer the second example. So from here, we know that where d is equal to, d is equal to what? D is equal to what? B over 2A. And K is equal to, uh-huh, K is equal to what? Okay, negative, uh-huh, B squared minus 4AC all over 4A. So that's the definition. So these are the formulas I'm talking about, okay? So instead of going through the completing the square to get the answer directly, the second method will be choosing the direct formulas. So let's use the question to apply with the formula to our example. So let's write this one. Find the minimum value of this our function. This our function. The same function here. So I'm repeating the question. 3x squared minus 2x plus 1. F of x equal to 3x squared. Okay. The same question. So, and what value of x does it occur? So, I choose the same function for you to know that if you use the completing the square and also maybe student A uses completing the square, student B uses the formula method, you must still get the same result. But in some questions, sometimes you're going to be restricted to use a particular format. Sometimes they'll give you the instruction by saying by completing the square or use completing the square to find the minimum or maximum value of this given function. So you must know how to use the completing the square and also how to use the what? How to use the what? Formula. Do you get it? So let's answer this question here. So let's keep the answer that we have. These are the answers, right? So the minimum value should be 2 over 3 and x occurs at 1 over 3. So let's do the solution for the formula method. So we have been able to define the method here. So let's write it again. So solution. The minimum value is equal to, hello. So the minimum value is equal to, let's define it. Then we do substitution. Okay, afterwards we do substitution. So let the function be defined first. Let the function to be f of x equal to 3x squared minus 2x plus 1. So that is the function. Then we should be able to know the corresponding values for A, B, and C. So where, let's say this, where A is equal to what? What is A? Compared to the general quadratic function, what is A? 3, and B is and positive 1. Okay. Now let's begin with our minimum value. Minimum value will be equal to, then say the formula, minus b squared minus 4ac over 4a in bracket. So we know our a we know our B and we know our C. So what we have to do is substitution. Okay? So wherever you see A, B, and C, we are going to put in the values by substitution. So let's do that. So negative, then B over here is what? Negative 2, right? So let's put it in brackets. Negative 2 squared minus 4AC. They are multiplying. So A is 3. So bracket. Then C is 1. So just bring the common bracket. Then denominator 4 times A. That means 4 times 3. Okay, let's find the final answer. So what will be the answer for the numerator? So let's do it one by one. We have here to be what? 4. Are you watching? Here to be what? Minus, everything here will be negative 12. Then here will be what? Positive 12. Now, this will give you negative what? 8 over 12. So break this one down. Negative what? Negative 2 on 3. Alright, let's write an answer at the back here. So we have negative over here, and the value contained in the bracket is negative. So when they multiply, they become what? Positive. And now our answer is what? 2 on 3. So using the formula method, you have been able to get the same answer compared to using the completing the square. Do you get it? But you must know the two, because in some questions you are going to be restricted to use a particular method. So we have here to be the minimum value is 2 and 3. The same goes to using the completing the square. Let's go ahead and find the value of x which occurred. So that one, the formula would be, so x is equal to, what will be the formula? The value of x which occurs, that's the turning point. What is the formula? The formula for the turning point. B over 2a. B over 2a. But you know already we know B and we know A, right? So let's do the substitution. Let's do the substitution. So let's keep in mind the answer should be 1 over 3. So from here, B is what? Negative. So we have x is equal to B. So B is negative 2. And we have 2 times what? The formula is negative B over 2a. Yes, negative B over 2a. Yes. So we have it here. So A, what is A? A is 3, right? So you are going to get x equal to negative into bracket 2 over what? 2 over what? 6. Then you simplify this. You are going to get x equal to negative 1 on 3. So when the negatives multiply, you're going to get x is equal to what? 1 on 3. Are you okay? Are you okay? All right. So you can use the formula method or completing the square. to answer questions under minimum or maximum values and the point at which x occurs. Let's continue. So you are going to help me to solve these questions under what we are discussing. So get ready. All of you come to the board. What is A? Yes, Joseph will come. Amakwala will come. Otu will come. I have all the names in the class. Where is Otu? Okay, so let's answer these questions together. Okay, so two people coming to the board. One person will use the completing the square. The other one will use the formula. Huh? Where is Solomon? So I'm giving you all this space to use for the completing the square. So the first person coming is coming to use completing the square. So I'm giving you 1 minute. Just look at the question and make your deductions from it. Plan for what you're coming to write within 1 minute. Then I'll point the person. You are going to use the completing the square, so prepare for it. All of you should try. Yes. So who is coming? You want to come? Just raise your hand. If you not raise your hand, yes, yes. Thank you. Starboy is coming. Are you the school prepared? Are you the school prepared? Okay. So it's going to use the completing the square method. Start from here, then can come here and come here to complete what you are doing. Yeah, no. Ah, you are enjoying it. Yeah. Hello, hello. Hello, let me take this one. So you have to be working to confirm a solution. Okay. So do it to confirm. I mean, I am not doing it. So you have to confirm whether is at the right one. So let me follow what you say. You are done. Okay. So before we confirm the, thank you, Sir. Oh, let's clap for him. Let's clap for him. Yeah. Before we confirm the solution, the second person come to use the formula method and see whether the answers are going to be the same. So for the formula method, you can use that space over there. Because I'm not going to write much. Yes, but I can do that. Use that space and use it wisely, okay? You don't have any extra space. Okay? Start from the top. Which one? No, 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 no. You not simplify this again. You just start it to be negative 2 x plus 1 over 2 also. So now positive again. Negative 2 multiply. Yes, because all of them were in a common bracket. Look at this one. It's in a common bracket. So the negative 2 multiply this thing and this thing. separately. So the negative 2 cancel the 16. Do you get it? Okay. No, this is not the answer, so you can't come out with answer. It is in a bracket. Okay. Negative 42. Oh, okay. So it's still. Okay. Do you have different answers? Look at the minimum. Is the maximum? Look at the maximum. The maximum value. For this one, we have positive but 1 over 8. And this one, what did you do to get a negative 41 over 8? But the value at which x occurs are the same. So what makes the difference with the formula and the completing the square method? What makes the difference? Have you find a difference? Have you also solved for it? Have you solved for it? Which answer did you get? Positive. Which one? Okay, brother. So you get answer. You get this answer. You did not square the b. You did not square the b. Come and correct yourself. All right. Since I've been able to derive with the same answer by using the completing the square and the formula, then that is it. So we can see the maximum values are the same and the value at which x occurs to are the same. Do you understand? Okay. So if you are covering the first, then let's move on to another aspect. You have 1 minute to have a block your anyone's view. Okay. You write fast. Okay, okay, I think you are done, right? Can I clean the middle? Can I clean the middle? Who is still writing from the middle? No one. Okay. Can I clean this part? Okay, some of you are still writing. Let me. So let's continue. Graphing quadratic function. We are going to learn how we can graph quadratic function. So we are going to learn how we can graph a given quadratic function. You need to know certain things, then we need to find that particular point or coordinate, then just graph it. So let's look at the steps. So first of all, you need to determine the position of the function. So look at the function over there. What will be the position of the function? Whether minimum or maximum? It is what? Minimum. So the function will be minimum. So we have a minimum function. The second thing to do is find the axis of the symmetry. Okay. So let's find the axis of the symmetry. That is the finding x. So we have x is equal to minus b over 2a. So let's define this. Where a is equal to 1, b is equal to minus 4, and c is equal to minus 5. Are you following? At the end of the day, I'm going to draw the function. And you're going to do the same. When I do my own, I'm going to give you tasks to also draw your own function. So pay attention. So we have to substitute the values of a and b over here. So we have b to be what? So into bracket, negative 4 over 2 times 1. So x is equal to minus negative 4 over 2. Let's continue from here. X is equal to minus negative, so cancel out this one, get what? Negative what? 2. And negative multiply this negative, get what? X equal to what? I hope you are following. We have X equal to 2. Okay. So that is the turning point in terms of the X. we need to also find the corresponding y, not a turning point to be a coordinate, right? So we have the x. What can you do to get a y? To get the particular point that can determine the nature where the parabola or the graph is passing, okay, where it is turning. So what can we do to get the corresponding y? We do what? We do what? Put what? The value for x that we are finding right now into the what? Into the function. Are you okay? All right. So this is what we're going to get. So put x equal to 2 into f of x into the function. So I can claim here. So let's find y. Let's continue from here. We have here, so y is equal to wherever you see x, you substitute to take it, all right. So we have here to x squared, which is what? 2 squared minus 4 times 2 minus 5. So 5 would be equal to 4 minus 8 minus 5. Use the calculator, give me the final answer. What will be there? Negative what? Negative 9. Negative, negative 9. Thank you. So negative 9. So now our turning point will be the form. What is the coordinate for x? What is the coordinate for x? 2. And what is the coordinate for y? Negative 9. So this is our turning point. What do we need again? We need the intercept, the x and y intercept. Okay, we need the x intercept. Only the x intercept. So let's find the x intercept. We need the x intercept, and it gives you the condition. What is the condition for x intercept? Y equal to 0. Very good. So let's do that. So we are going to put y to what? 0. So we have the function 0 equal to x squared minus 4x minus 5. Okay, so let's find. So what have you gotten here? The roots of x, right? So I'm going to find the root of x. So the same as x squared. So let's equate it to 0 instead in this form. We are going to use the calculator to find the roots. So use the calculator to give me the. So x is equal to what? 5 or x is equal to what? Negative 1. So now therefore x intercepts are the first one is 5 0 because y is equal to 0, right? So 5 0 and negative y 0. So look at what we have solved so far. We have been able to get the vertex, that's the turning point, this one. And which one again? We know the nature already. That is minimum. Good. So if it is minimum, where is the parabola drawn to? Where is it facing? It is facing, is it upwards or downwards? Is it upwards or downwards? Don't worry. When we sketch, the picture will come by itself. Now, okay, now let's sketch this. So let's use the graph to draw our parabola. So it is what? Minimum. So it will face where? Upwards, right? Okay, so let's draw the x and y axis. Where is the ruler? So take your graph and do this. Let me use the black. Draw your Okay, so let's represent our points that we have on the graph. Let's label the axis. Okay, let's do something here. 5 is 1, 2, 3, 4, 5. Yes. It will not reach 9. We need the negative side of the y to be 9, right? We have to we have to take the x axis upwards. So let's take it upwards. So let me see. Can you see from the point? So sometimes you need to manage the graph, okay, to suit the nature of the question. So now the x-axis has closed the positive part of the y-axis. Now let's plot our given points in the graph, starting from so we are supposed to plot the x-intercept, okay, and the vectors, the vectors. So we have here to be 5, 0. So here will be 5. So 5, 0 exactly on the line. That is 5, 0. Then we have the other one to be negative 1, 0. Negative 1, 0. I want the graph to look nice. Let me shift this one to this side. Okay. It will not, it will not show well. So let's plot the intercept again. We have here to be 5, 0. And we have here to be negative 1, 0. Well, which one again? Which one are you going to plot? The so what is it? 2, negative 9. So let's show it here. 2, negative 9. Okay. Then what are you going to do again? Where is the do you have another point to plot? The y-intercept. We have to do the y-intercept. So let's do that one then to plot. So x is equal to 0. So we have the function y is equal to x squared. So we have the x to be 0. So 0 squared minus 4 times 0 minus 5. And y is equal to what? Minus 5. So in the coordinate form, the y-intercept is equal to what? 0, negative 5. So let's plot that one. So we need the x-intercept, y-intercept, and the turning point. Okay. So let's plot the y-intercept. 0, -5 here. 0, -5. Now let's draw our parabola with your free hand, but make sure it passes through the points that let's plot. You know something? Let's locate the turning point before we sketch. Then see something from here. So this is supposed to be our turning point. Look at the calculation. Look at what you're coming to add up here. Now, from the y-intercept to the turning point, how many units do we have? 2. Let's count it together. Please pay attention. From here to here is 1, right? Then to 2. Then you repeat the same 2 units to the other side. That's where the parabola will pass. Don't just draw the parabola anyhow. Okay? So from here, you have from here to here is what? 2 units. I hope you are paying attention. So we have here to be 2 units. Then from the the point where the parabola curves to the other corresponding side will also have to be 2 units. So and with the 2 units, the coordinates here will be also noted down. So the coordinates here will be what? Let's read from here. 4, -5. So this is what you will need to draw the parabola. Yes. Yes, you have to show this. The 2 units and this. It is necessary. If you show it, it's not wrong. Right? That tells you the direction of the parabola, where it should pass. Then let's draw. So let's draw the parabola from here. We have make sure it passes through all the points. So using a free hand, you get something like this. Do it better. Make sure it passes through all the points. Okay? Make sure it passes through all the points that we have plotted. So we have this one, the turning point, this one, and the intercept. I hope you are getting this. We are going to draw another one. So finish drawing, then let's do another one. So this is our first question. Can I clean? So this is our second question. Y equal to -x squared plus 6x minus 3. Okay, so let's draw this one too. By the time we finish this one, then I think everyone can draw the graph of a given parabola of quadratic function. And with this one, I'll be calling you to come and help us with the sketch. So you should prepare yourself. So let's begin with all the points that we need. We need the x-intercept. We need the point, the turning point. We need a y-intercept. That's what we need. And x intercepts the turning point, y intercept. And inside the graph, our 2 units coordinates also appear. Okay, so let's look at the workings. So beginning with the turning point, right? So x is equal to negative b over 2a. So let's note the variables. So where a is equal to okay, so go and write, take this, the values for a, b, and c. And let's continue this side. Okay. Okay, so I'm also going to call someone to come and do the substitution for us. If you're ready, just raise your hand. The substitution for this x value, for the x. The substitution for the x. Okay, come for a marker. Okay, also find the value for y. Use the x to find the value for y. Use here. Rule a line here and continue. Then if you finish, then write it in the form of the vectors. I hope you're also working for it. So is that so write it equal to the vector is equal to, so that when we are plotting it, that is equal to negative x. Take the calculator. Okay. So let's check from what you have, your results. Do you get the same result? Okay, now let's also look at the x-intercepts and y-intercepts. Yes, x-intercept. Mhm. There was a calculator there, so don't worry. Hmm. The y-intercept. Go and show it for us. Thank you. Go and show it for us. Yes, they are waiting for you. Which one? Which one? The y. Okay, go and correct it. Go and correct it. Give me my mark. With the same expression. With the same expression. You show 24. Point it to me. It's not. Then what about this? This is positive, right? Thank you. All right, so let's do the x-intercept. Mm-hmm. X-intercept. Oh, sorry. Law. Okay, Lawrence, come for the marker. Glory. Florence. Okay. X-intercept. X-intercept. Hurry up, hurry up. X-intercept for the turning point. Which one? It's affected negative. Yes. The square after the negative. Mm. So you have to put it in brackets. It must be in brackets. Mm? Which one? Which one? And A is what? Okay. So what you have? Is it true or false? Are you sure? We have the x-intercept. Is that so? Uh-huh. Any problem? Okay. You go. Whatever you say, go ahead and write it. Please, the x-intercept, I will not accept to. Eh? How can it be a complex number? What about the x-intercept? Huh? Negative x squared plus 6x minus 3. Use a calculator and give me the roots. That's what I'm going to get. Oh, okay. So let's run it to the nearest whole number and see. Okay. This is what the question is giving us. So unless we solve before you know the values. So let's run it to the nearest whole numbers. So which you are going to get this as 5 and this, the other one as what? 1, right? Let's try that one. So we have here to be x equal to 5 or 1. Then we have here to be 5 0 and 1 0. So that's what the question gives us. So we need to use the value that you also get. Then it is left with y-intercept. 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 Yes. Who is Kekele? Kekele. Are you ready? Y-intercept. Oh, that one is simple. So why are you delaying? Mm. We are supposed to use 3 minutes for exercise. So let me leave you to for you to do the y-intercept and which one again? After y-intercept, that's all. Then you draw the graph. I'll come and inspect. So do the y-intercept and draw the graph for me to come and inspect within 5 minutes. Within 5 minutes. Are we able to draw? Oh, this is the old one. The new one. The old one. Let's Yes, it is your exercise. So do it after that. I'll check everything. If you have gotten everything, draw the graph. Okay. So if you are done, let me see your work. You will not present it on the board. I want to see it. I just want to see it. If you are done with the graph, let me see. Yes. So let me see how the graph looks like. Then continue to different aspects. This is the, this is the graph. This is the old one. What is the new one? I will get the other point graph and then see how it looks like. Since we had the intercept to be in decimals, I just want to see how the graph looks like. Then we continue. We're not going to do it on the board. Yes. So we are continuing. When you adapt the graph, just let me see. Okay. Is that a graph? Is that a graph? Is it this graph that you are done? The new one. Is it the new one or the old one? So finish and let me see. Don't forget your unit two. Okay. The point. Look at this. This is it. And where is the y intercept? Is here. So, so this is the graph that you have gotten so. Okay. Look at this. Someone saw. So we have a graph here. So try and get the same. Okay. Let's continue. Let's continue. Solving quadratic equations. So we have hello, hello. Is it working? Hello. Okay. We have different methods that we can also use to solve quadratic equations. So we have the factorization method, we have completing the square, and the use of the almighty formula. So we are going to do all the methods here. So we are using the factorization method to solve the equation 2x squared minus x minus 1 equal to 0. So we are finding the root. I hope you are familiar with these kind of questions. Without using calculator, can you do it? Okay, then I need two people to come to the board. No calculator. Yes. Come and solve this problem for us to continue because we have a lot to do. Uh-huh. Come and take one. Another, I need the second person should be female. So as you are coming, come along with one lady. You choose one lady and come along. Hmm? Where is she? So, and who is that lady? She. Come and they are mentioning your name. Please come out. Come. Come. So solve the first one. And then trying to do it. Yes, one lady. Yes. Miss move. I'm coming. Sorry. Yes. Hmm? Go and try. First, find the factors over here. Then go and just put it inside. Yes. Do the second one for us. Yes. I asked you to bring some wine. So do it. Do the second one. The other side. Divide it. Or you can write. You can write inside. Use it. So, by the use of the method of factorization, you have to use the coefficient of the highest power of x to multiply the constant. Find its factors, test the combination of the factors that will give you the products of that particular constant, then find the combination of the sum that will give you the middle term. Then use that factor that satisfy the equation, then use to expand. Is that so? That is the calculator, right? Very good. Thank you. All right, so let's proceed to the second method, that's the completing the square, and let's do it together. If you are copying, be fast and let's move. Can I clean the board? You can see some people are right. Hurry up. Hope I can clean this. Let's pass. So let's use the completing the square method to find the roots of these given equations. So let's do the first one together, then the second one, you also do it. Okay, so let's solve the first one. So we have the equation to be 2x squared minus 3x minus 1 equal to 0. This time it is not in the function form. This is an equation, right? So completing the square over here is a little different from the function form. So let's apply the concept here. But still we need to let the coefficients of the highest power to be what? To be what? 1. So this time we are not going to take the common factor, but we are going to do what? Divide through by coefficient of the x squared. So let's do that. So we have here to be over 2 over 2 over 2 over 2. Right? Now we have to cancel out the coefficients of the x squared. Now we have x squared minus 3 over 2x minus 1 over 2 still equal to what? 0. Then the next step is let the constant go to the other side of the equation. Okay? So this is a constant, the one without any variable. So we have x squared minus 3 over 2x equal to what? Positive 1 over 2. Now apply the same concept. Let's divide the term with the x, okay, over 2. So let's divide by 2. Then you add the square to to both sides. This time it is not adding and subtracting, okay, at the same time, but we are adding the square of it to the both sides. Do you get it? Okay. So we have here to be x squared minus, then it will be what? 3 over what? 4x. Uh-huh. Yes. Continue. Mm-hmm. Plus negative 3 on 4 squared equal to 1 over 2 plus negative 3 on 4 squared. Let's take let's get our perfect square from this. So we are going to get x minus 3 on 4 squared, then equal to, so let's work out the bracket here. So we have, okay, so we have 1 over 2 plus, expand this one, we are going to get what? 9 on 16. So let's take away the bracket. So we have x minus 3 on 4 equal to, so what is the 17 on 16? Okay. So what are we going to do? Square root to both sides. So let's do it here. Okay, so the squared here, we cancel the square root. We are going to get x minus 3 on 4 equal to the square root of 17 over what? 4. Now we're going to make x the subject, right? So we have x equal to, yes, any question? Yes. So we are making the x the subject. Okay. So the values that we are going to get here will be plus or minus. So let's continue. We have positive 3 on 4 plus or minus with 17 over 4. And this will be the values of x. So if you want to write them in separate form, it will be 3 over 4 plus root 17 on 4, or x equal to 3 on 4 minus root 17 on 4. Hmm? Do you get the same thing? Let's look at the second one. Let's apply the same completing the square for the second one. So if you are writing the first thing, let's do the second one. So let's start from here. So you are supposed to complete the square, okay? Use the completing the square. So now look at this one. The coefficient of the highest power of x is already 1. So just need to just divide the x term. So we have to just take the constant to the other side before we divide the x term by what? 2. So we have here to be x squared minus 6x equal to what? Negative 7. I hope you are following. Okay, so someone should help us with the division of the x by 2. Mm-hmm. Yes. Who? Who is Fidaus? I will continue. Okay, thank you. Thank you. So let's make this one. So from here, they come here. So you just have to use the procedure for completing the square to find the root of any given quadratic equation. Right. Let's look at the last method by using the quadratic formula. So those writing the first and let's continue. Okay, I hope you are finished writing. Are you finished? From the middle. You write it from the middle. Oh, yeah, the middle. This one. Okay. So the third formula will be the quadratic formula. So we have our quadratic formula. Then when the quadratic function equation is given to you, just look at the variables that we have there, a, b, and c. Be able to write them from the quadratic equation. Then substitute into the formula. They get your values of x. So let's look at an example here. So we have here to be 3x squared. We are using a quadratic formula, okay? So we need to find our a, b, and c. So what will be our a? Yes, positive 3. And the b and c. Okay, so let's substitute into the formula. So x is equal to a negative b. So we have b here to be negative 4, right? Let's first substitute before you find the result. So negative into bracket negative 4 plus or minus square root of b squared. The b squared is negative 4. So negative 4 squared minus 4, where is a is 3 and c is negative 1 all over 2a 3. Yes, yes. Oh, okay. So let's use the calculator and find the values first. So x is equal to, this will give you what? Okay. Then the square root, this will give you what? 16 positive of all over 6. So x is equal to 4 plus or minus. What will be the result inside here? 16 plus 4, 28. 28 all over 6. Okay. So let's write this in separate fractions. So we have 4 over 6 plus or minus 1 over 6 is 28. So you can reduce this one to be x equal to, it will be what? 2 over 3 plus or minus 1 over 6 is 28. Obviously, that's the final solution, right? Okay. We can also write the answer in decimal if the question demands to. Okay. Okay, let's also look at the root of quadratic equations. The root of quadratic equations. Can I claim or you are writing? So if you simplify, what will be the perfect square number? Yes, that is 4, 4 times 7, 5, 2 and 7. So you can simplify it. Hurry up and let's continue. Are we finished? Okay. Yes. So let's write this point down. Okay, so let's look at the notes we have on the board. We are looking at the nature of our given quadratic function. So we are talking about a discriminant, and it is being taken from our quadratic formula. Okay, I hope you are familiar with the discriminant. So that is b squared minus 4ac, following certain conditions, right? So that is what we have on the board. So when it is greater than or equal to 0, it has two real roots. When it is greater than 0, it has two real indifferent roots. When it is equal to 0, we have two real and equal roots. Then when it is less than 0, complex roots, right? So let's look at question that they will ask us to use these discriminants to describe the roots. let's test for the first one. So we need to use the discriminant to test for the nature of the roots. So first you need to write the expression for the discriminant. That is b squared minus 4ac. And it is equal to what? Equal to what? Let's put in their values a, b, and c. So let's first note this one down. So a is equal to 2, b is equal to -1, and c is equal to. Okay, so let's substitute this inside. We have -1 squared minus 4 multiplying what? 2, and where is the c? -1. So what is the result here? Let's do it small. So we have 1 minus that plus 8, and you are going to get what? So what is the nature of this? It is what? It is greater than. So what is the nature? Two real and different roots. So we are going to say that this one is greater or greater than what? 0. So the description is it has two real and different roots, right? Okay, so let's look at the second one and the third one. So someone should come and help us. Come and identify the values for A, B, and C. State your discriminant, substitute, and let's see the answer you get. Then you use it to describe the nature of the quadratic function. Because I've not been to the board before. Are you sure? But I can do it. Can do it. Are you sure? Maybe lying. You follow what you have done for the first one. Do it. State the A, B, C, and then substitute inside the B squared minus 4AC. The answer you get, use the explanation to describe it. And the second question. So describe what is done. Look at the description over here. Negative what? What of four. So what is the description attached to this? Number four. That is two. Okay. Thank you. It's left with number three. Huh? I come to do number three. Okay. Clean the first one. The top one. The first one. Okay. Thank you. I hope everyone can use the discriminant, right? Okay. Now let's begin the polynomial function. So all these are under the types of the polynomial function. So let's talk about the polynomial function itself. Yes, I know true. What did you get? Yes, really. Is that only you or your friends are doing the same? Okay. So let's continue. So let's talk about the polynomial function. So from the beginning, we discussed about the types of polynomial function. And we started from the linear function, then we also came to the quadratic function, right? So we also described these differences with their exponents, the highest power. Now the polynomial function starts from the power of the highest power of the polynomial function start from what? 3 and above. So we have root 4, exponent 4, exponent 5, and so on. But to your level, we stick to exponent 3. Do you get it? So the polynomial function with the power exponent 3, where the coefficients are the constants. So A, B, C, and D are all what? Constants. So in case if you want to look at the nature or the graph, I'm not going to draw the graph, the nature of the polynomial function, look at the coefficients of the highest power. If the coefficient of the highest power is positive, so if A is greater than 0, then the function will look like this. If A is less than 0, then the function is going to turn it down like this. But we're not going to have a specific example to draw the function, but look at how the function will look like. Okay. So we are straight going to look at the algebra aspect of the polynomial function. Okay. That is the addition of polynomials and multiplication of addition and subtraction and the multiplication of what? Polynomials. So let's straight look at the algebra aspect of the polynomial. Example. So we are finding number one. Find f of x plus g of x. If f of x is equal to 3x cubed plus 4x squared minus 2x plus 8, and g of x is equal to 2x cubed plus 3x squared plus 5x plus 2. So whenever we are being asked to find the addition of polynomials, we need to add their coefficients, right? So let's express this in terms of the vertical form and add the coefficients, and we'll deal with it. So let's arrange this. So we have here to be 3x cubed plus 4x squared minus 2x plus 8 plus, then we have here to be 2x cubed plus 3x squared plus 5x plus 2. So we put this in brackets. So let's find um, the addition of the like terms. So let's start from here. So 8 plus 2. Please, this one you don't do any carry forward. Eh? Okay. Then this one will give you what? Positive 3x. Then this one will give you 7x squared. And this one also gives you positive 5x cubed. So this is the answer you are going to get. You just add the like things. Let's go at number two. So let's solve this one too. So we have two given functions. F of x is 3x cubed plus 4. And g of x is 2x squared plus 3x plus 5. Since we are adding these two functions, we need to add their coefficients. So let's write this in the vertical form. So we have here to be 3x cubed plus 4. Then this one, now we need to complete, we need to complete all the terms in a function, whether it has been given or not. Okay, for you to get the arrangement in order. So complete. If it hasn't been given, place the coefficient with 0. Are you okay? So let's do that. So let's complete this one, the first one. This will give you, so we don't have the x squared term. So we have to be 0x squared plus, plus 0x. Then the constant is there, plus 4. Just complete it. Okay. Then we have this one to be, there's no x cubed. So we have 0x cubed plus 2x squared plus 3x plus 5. Then you add the coefficients. So let's start from here. You get 9, 3x, 2x squared, 3x. And that's the answer, right? So completing the missing terms will be very easy for you to just add everything together. So let's look at the subtraction part of the polynomials. We also do the same thing. So let's look at two examples for this one. So we are just solving one example for the subtraction. Okay. Then we continue. So let's use this example. So we are going to write this in a vertical form and subtract the coefficients. So we have here to be 5x cubed plus 2x squared plus x plus 5 minus, then break a bracket. So we have 2x cubed. We have the x squared term, so then 0x squared plus 4x plus 8. Then you subtract the. Now you know this 8 is negative because of, okay. So 5 minus 8, negative 3. Then let's come to this one. This is also negative. This will also give you what? Negative 3x. This will give you positive 2x squared. This will give you positive 3x cubed. So that is it. Do you have any question on this? So those writing, hurry up and let's move on to the multiplication aspect. So it's time for you to do short exercise. So the exercise will come from the multiplication question. So just give it to us exercise. I hope you can do that one. So let me give you one question on multiplication. Can I change this one? So try this one within 5 minutes. Start with if. So you finished before. There are two functions. You are supposed to multiply them. Are you doing it? Feeling? How's it going? I don't. So this one. Notification. It is a big no. Big no. That notification. Hello. Our voice come on. Again, so it's a surprise. Let me also check that. Ah, oh my God. Let me see. Direct. You want to present it on a board, something like that. Let me see what we do. Let me see. Let me see one solution. Very good. Yes, you're on point. Take it. It's not for you. Yes, very good. Okay. No, no, this is not what we do for the competition. Really. So, but we want the one project. Spread them into separate brackets. They like in terms of the two brackets they just have. Actually, you come up with that one. It's when it is done. Yes. Let me see. Let me see if there's one that you at my eyes and the page. Very good. My eyes are good. It's not. You have to put them in two brackets and expand. Okay, okay, it's fine. So if my marker is with you, then come along with the marker. With that. Yeah. So from there we go to the division of polynomials. Hello? 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 So where's the final answer? This one. Okay, so so who has a similar answer to this? The same thing. Yes. What about you? Honorable. Do you have the same answer? Hmm? Okay. Let's look at the division of polynomials. I hope all of you can do the multiplication. Those who are doing something else, please look at this and next time. Let everything be A1. Okay? Let everything be A1. I'm just here at A1. We are going to look at division of polynomials. We have two different types. What are they? We have two different ways of performing division of polynomials. One is by using long division. The other one is what? Uh-huh. What is the meaning of it? Is that the formula? So long division and what? Long division and syntactic division. That one is very short. If I introduce it to you, you forget about the long division. Do you do it? So let's start with long division. You know how to do that one. Then let me give you a question on that. Then we do the other one. Yes. Okay, so I want to introduce the second method to you. That's the synthetic division, right? So you are coming to do the long division. Then, so question number one, use long division to do it. Then the same question number one, I will also use the other method, synthetic division. So who is ready to come and answer the question number one? Can I clear this one? Yes, sir. Yes. You know the long division already, so someone should come and do the long division. Then I will introduce the other one for you. Okay. Do it at the other side. Oh, go up small so that you can have enough space. So what is the answer? Write the final answer. Express this in terms of fraction and equate to the answer. Equal to. So that is it. Okay, so let's look at the other method. Can I clean here? So the long division is the first method. Then the second method is the synthetic division. So what is the question? So we have x squared plus 2x minus 8 being divided by x plus 4. Okay, so this is a strategy. Pay attention. This is a strategy. So first off, the first thing that you need to do is equate the factor given to you that you are being asked to use to divide that particular function. Okay, the factor given to you is x plus what? 4. Equate it to 0. That's the first thing you have to do. So x plus 4 is equal to what? 0. Then find the value of x. That's what we need to do the division. Okay, so x will be equal to what? Minus 4. And I'm going to draw the synthetic division table. This is it. Okay, then this negative 4 will come here. It's very interesting. Just open your eye. This negative 4 will come here. So we have it here. Then look at the function given to you and write the coefficients of all the terms. Okay, so let's write 1. So separate them, negative 8. Good. Now we're going to start with the division. Now the first number that we have here, bring it down. So bring arrow indicating you are starting with the first number. Okay, you bring this number down. Always the first number that you get here, no matter the number, whether it's 2, 3, any number, you bring it down to start with the division. Now the strategy is use the number here to multiply this number. What will it be? And write that negative 4 over here. Hello, let's continue. Then what we have here, you are going to add. So add these two numbers. What are you going to get? Negative to write it down here. Then this is where we are right now. Okay, we are going to use the number here again to multiply the negative 2. What are you going to get? Positive what? 8. Then add again. What are you going to get? 0. We are done. So let's write our coefficient. Okay. Now look here. When the polynomial here, when it is defined to you in a certain power, the answer here reduce the power by one. Okay. So the highest power is what? 2. So the answer here, the first term here, the power is what? 1. So always the power is being reduced by what? 1. So let's list the coefficient. So when we write a coefficient, we have to add the necessary variable that have been attached to the terms. Are you okay? So over here, I'm going to say that 1x, not 1x squared. Okay? So over here, we are saying that x, 1x is the same as x, right? Then this becomes